Hello everyone, welcome back. In today's video, we are going to learn how to create a series from a list, a NumPy array, or a dictionary. So first of all, we are going to create a series from a list. First of all, this is my list. This is the list of integers. It has 5 elements, 10, 20, 30, 40, and 50. And these are the indices A, B, C, D, and E. So we are having 5 elements with 5 indices. Now I would like to create my series. I call it series underscore list. In order to use the series function, we need to use it from the series function of the Pandas library. So in order to create the series, I call the series function from the PD, and we assign the data to be equal to data list. So our data equals the data list. So the list of our data that we created here. Okay. Our index equals the index list because we're having already a list. We could also put this one. We could also put this one here. It's optional. But in order to keep the code clean, we can create our list, data list, and index list separately and simply write down the name of the data list and index list here when creating the series using the series function from the PD library. So we are having the index equals index list, and the data type is integer. So we write down d type equals int, and the name of the list we can name it whatever we want. I choose to say list series, and this is basically how our series is created from a list, a data list with its corresponding indices. And we are going to then in the next line print it in the output. So when we look at the output, we see that series from list, exactly this message, series from list, A as the value 10, B 20, C 30, D 40, and E 50, exactly as we were having here. So A 20, 20, A 10, sorry, 20 B, 30 C, 40 D, and 50 E. Then we are seeing that the name is the list series, exactly what we chose here. And also we are having its data type, which is integer. So this was the first part. Then we move on to creating a series from a NumPy array. In order to create a NumPy array, we can use the array function from the NP library, which is the NumPy library. We call it a data array here. Okay, so we call it data array. And we are going to have these elements from 100 to 500. So these are the elements of my NumPy array. Then I would like to index them as well. So I like to have the indexing from uppercase A to uppercase E. Then we have the index array with these labels. Okay, so we created a data array with these elements and the index array with these labels. Then we are having the creation of our series. We call it series underscore array. I call the series function from the PD library. I assign data to be equal to data array that we created just now. Then I have the index equals index array, that is A from A to E. The data type is integer and we give it a name, and the name is array series. In the next line, I'm going to print this series underscore array. So when I run the code, we see this is my series created from the NumPy array. So A 100, B 200, C 300, D 400, and E 500. And the name is array series, exactly like the one that we chose here. And the data type is integer. Now, let us talk about creating a series from a dictionary. In order to create a dictionary, we know that the dictionary is a key value pair. So this is, for example, the first key, and this is its corresponding value. This is the second key. This is its corresponding value, Z, and this number. So this is the dictionary called data underscore dictionary. And these are the keys X, Y, and Z, and these are the values 100, 1000, 2000, and 3000. Okay, so now we would like to create our series from this dictionary. We name it series underscore dictionary. We use the series function from the PD library. We assign the data to be data underscore dictionary that we created here. So here we don't have to have a separated index dictionary for the keys, because index is automatically taken from the dictionary keys. So when we are creating a series from the dictionary, we don't have to have the indexing, because here, for example, when we were creating a series from the NumPy array, we were having the data and indexing, okay, and indexing. Here we are just needing the data, because index is automatically taken from the dictionary keys, which are X, Y, and Z. So we only assign data to be equal to data dictionary. Then the data type, we know it's integer, and we give it a name, which is dictionary series. And then we are going to print this dictionary series. And we see here we are having X, it's 1000, Y is 2000, Z is 3000, and the name is dictionary series, and the data type is integer. So finally, we are going to learn how to create a series from a scalar value. Our scalar value is 99. So we are having a single scalar value, and we would like to create our series from this scalar value. So we name it series underscore scalar. Then we use this series function from the PD library, and we are having data equals scalar underscore value, which is this variable, which is 99. And then for indexing, we didn't create an index, for example, array separated here in the code. We are directly creating it and using it in the series function. So index equals 1, 2, 3, meaning that we would like to have three values for these three indices. Then we are having the data type, which is integer, and then we are having the name of this series, which is called scalar series. And then we are going to print it in the output. So we see that for index 1, we are having 99, for index 2, 99, index 3, 99, and the name is scalar series, and it's of integer data type. So here we learned that even with a single scalar value, we can have three elements here. You see a series with three elements, and because we were having three indices here, we realized that okay, we would like to have three elements using the same scalar value. So in this video, we learned how to create a series from a list, from a NumPy array, from a dictionary, and also from a scalar value. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to access elements using index labels and positions. So first of all, we would like to create a series with custom index labels. So this is our data list containing from 10 to 50. And this is my index list, which is having A, B, C, D, and E. So now I would like to create my series called series underscore list, and I use the series function from the PD library. Data is assigned to data list, which I created here. Index is assigned to index list that I created here. The data type is integer, and the name is example series. So here I created my series from the list, and we are first of all printing this series. So we see that this is my series. This is the original series. For the A, we are having 10, B 20, C 30, D 40, and E 50. And the name of the series is example series, and its the data type is integer. So we see that we can create a series with a custom index labels. Now, how can we access elements using the index labels? In order to do that, first of all, for example, we would like to access a value at label A. So here we saw that label A was for 10, B for 20, C for 30, D for 40, E for 50. But how can we now access values at label A from this series list? In order to do that, we need to write down the name of our list, which is series underscore list dot. We are going to use this function look. It comes from the location to access elements using index labels. So we write down LOC, and in square brackets, we write down the label of the value that we are looking for, A and C. So the label A corresponds to number 10, label C corresponds to number 30. So I would like to find the value that corresponds to label A and label C. In order to do that, we write down the name of the series dot loc, and in square brackets we write down the label that we are looking for its value. So now we can find the number 10 and 30 in the output because we are using the print function to access these two the values of these two elements, these two labels. So we see that here in the output we are having accessing elements using index labels. Element at index A, it's 10. Element at index C, it's 30. So here also we learned how we can access elements using index labels using the .look function. Then it's also possible to access elements using integer positions. So here we see that in order to access the first element, we write down the name of the series dot iloc, and in square brackets we are having the position or let's say the index of that element. So here this is the index 0, index 1, index 2, index 3, and index 4. We are having it here, as you see. Now I would like to access the element with index 0 and the element with index 3. So you see I'm calling the iloc function for the series list, and in square brackets I have the index 0 and index 3. So this way we can access the number 10 and number 40. We are using the print function to call the value corresponding to the index 0 of the series list using the iloc function. We do the same for the index 3. So when we come here in the output, it says element at position 0 is 10, element at position 3 is 40. So element at position 0 is 10, element at position 3 is 40. So this way we could also, it is possible for us to access elements using integer positions. Now we would like to access multiple elements using index label. So here was how we were accessing the values using labels, but now we would like to do it with multiple elements simultaneously. Again, we use the print function, then we call the lock function for the series underscore list, and there we are going to have multiple labels here, as you see. So A, C, and E. So A, C, and E. So we expect to see 10, 30, and 50. So we are calling multiple values using multiple labels. So when we are having it in the output, we see that accessing multiple elements using index labels, A, 10, C, 30, and E, 50. So we see it here in the output. So this also helped us to learn how to access multiple elements at the same time. Then we can have the access to multiple elements using integer positions. We use the name of the series .iloc, which we used for accessing one element at a time using in the integer positions. So we use the iloc, and then we are having multiple integers position. So we want to access the element at index 0, index 2, and index 4. Index 0, index 2, and index 4. So it's 10, 30, and 50. But we can access them simultaneously here. So we see that here we are having the A equals 10, C is 30, and E is 50, as we see it here. So accessing multiple elements using integer positions, accessing multiple elements using integer positions, A, C, E, 10, 30, and 50. Then we are going to learn about slicing. So we can have the slicing a series using index label. In order to do a slicing, it means that, for example, this is my original series. This is my original series. We're going to have a subset of it. Okay. In order to do that, we can have the print and use the log function for the series underscore list. But here we are going to say start at B, at position B or label B, and end at label D, and they are inclusive. Okay. So start at label B, end at label D. So start at label B, end at label D. It means that we are going to have B, C, D that corresponds to values 20, 30, and 40. So we see that here, slicing a series using index labels, it is having B, C, D, 20, 30, and 40. So this is how we can have the slicing of a series using the index labels. So we are creating a subset basically. And then also we can have the series slicing a series using integer positions. In order to do that, we call the iloc function for the series underscore list, and in square brackets, we write down the positions that we want to include, but we need to be careful because the ending point, which is here number 4, is excluded. So when we are writing from 1 to 4, it means that we're going to go from 1 to 3. The ending point is excluded. So we are going to get elements from positions 1 to 3. So position 1 is here, position 3 is here. Anything that is between them. So 20, 30, and 40. And we see here in the output slicing using integer positions 20, 30, and 40 along with their labels B, C, and D. So in this video, we learned how to access elements using index labels and positions. First of all, we created our series from a list with its index list. Then we learned how to access one specific element using the label, using the index, and multiple elements using labels, multiple elements using indices, and then how to do slicing using index labels, and how to do slicing using integer positions. Thank you for watching. Welcome back. In today's video, we are going to learn how to perform basic operations. So we are going to first of all include the libraries. We are creating a pandas series. So this is my data, this is my index. We use the series function from the PD library and we call it series. The data equals data. So the original data equals this data, and the original indexing in our series equals this index label list. Then the data type is integer and the name of it is example series. So first of all, for the reference, we print the original series. A10, B20, C30, D40, and E50. So we are having it here. Then we would like to perform basic arithmetic operations. In order to do the basic arithmetic operations, first of all, we are printing this in the output. So we see that this is what we are printing here, performing arithmetic operations. The first one, we're using the print function, adding 10 to each element. Okay, it means that the first element is 10. We would like to add 10 to it, so it will be 20. So the second element is 20. We would like to add a 10, so it will be 30. And so it will be 40. This one will be 50. This one will be 60. How can we do that? We write down the name of the series. In this case, the name of my series is series plus 10. So when we run the code, we see that adding 10 to each element is performed. Now, instead of having A equals 10, we're having the label A having the value 20, label E having the value 60. We can change it to any number. We can change it, for example, to 30. So we can add 30 to each element. So if I run the code now, we see that the label A has value 40 instead of 10. Label E has value 80 instead of 50. So basically, this is how we can add add a number to all the elements. Then in the next phase, we are going to do the multiplication. So how can we multiply all the elements by 2? In order to do that, we write down the name of our series multiplied by 2. So here we see that the original series is like this: 10, 20, 30, 40, 50, and everything is multiplied by 2 here. So 20, 40, 60, 80, and 100. We can multiply by 5, for example. If we are looking for something else, we can multiply it by 5. So if I run the code one more time, we see that we are having 50, 100, 150, 200, and 250. Depending on what we are looking for, we can modify this. So this is 2. Then we can do the square. So we can calculate the square of each element. So here is the square. We see that squaring each element is like this. So the first element of the original one was 10. Square of 10 is 100. So the second number was 20. Square of 20 is 400. Square of 30 is 900. Square of 40 is 1600, and a square of 50 is 2500. So we see this the square of elements is being printed here. And finally, if we want to divide each element by a specific number, we can have the series divided by 5, and this is the division label. So we need to have the slash. Series slash 5, it is going to divide all the elements by 5. So the first element is now 2. It was 10. 10 divided by 5, it's 2. Then 20 divided by 5, it's 4. 30 divided by 5, we are having 6. 40 divided by 5, it's 8. And 50 divided by 5, it's 10. So we see that we can perform these arithmetic operations to all the elements of a series. We can do the addition, we can do the multiplication, the square, and the division. Thank you for watching. Welcome back. In today's video, we are going to learn how to filter a series based on certain conditions. So we are creating a Pandas series based on the data and indices here. So you use the series function from the PD library. We call it series. The data in this series equals this data list. Indexing in this series equals the data labels. The data type is integer, and the name of it is example series. So first of all, for the reference, we print it here in the output. So this is the original series: 10 with label A, 20 with label B, 30 with label C, 40 with label D, and 50 with label E. Then we are going to do some filtering. How can we do that? For example, we would like to filter the elements of my series based on the values greater than 25. In order to do that, we write down for series, for the series called series, each element that is larger than 25, we are going to print it. So we see that here for filtering elements, values greater than 25. So values greater than 25, this is this message. We're having C larger than 25, yes, so 30 is being there, D is there, and E is there, 30, 40, and 50. Basically, it was checking like this. So 10, is it larger than 25? No, it's not true, so nothing happens. 20, is it larger than 25? Nothing happens. 30, is it larger than 25? Yes, this is true. So number 30 with its label is being printed. 40 is larger than 25. Yes, it's true. So 40 along with its label is being printed. 50, is it larger than 25? Yes. So we are going to print it along with its label. Okay. So now we would like to filter for values less than or equal to 30. So we write down series, each element that is lower than or equal to 30. Okay, this is the condition based on which we are filtering. So numbers that are lower than or equal to 30, it is going to go like this. So this is the output first of all. It is going to check 10. Is it lower than or equal to 30? Yes, so 10 is there. 20, the second element. Is it lower than 30? Yes, so 20 is there. 30, is it lower than 30 or equal to 30? Yes, so 30 with its label is there. But 40 and 50, these two elements are not lower than 30, so they're not passing this condition, therefore we don't have them here. So values less than or equal to 30, and we are having them here. Okay. Now we can have another filtering example. For example, we can filter for even numbers. So for that series, each element that is divided by 2 and the remainder of this division equals 0, it means that that number is an even number. Okay, so we are going to check if a number is divided by 2 and the remainder of this division equals 0, it means that that number is even number and we want that number. So we are filtering even numbers. We would like to get the even numbers. For this, we are saying 10 divided by 2, the remainder equals 0. Yes, so we are having 10. 20, is it when it is divided by 2, the remainder of this division equals 0? Yes, so we are having 20. The same goes with 30, 40, and 50 because all the elements in my original series, they are even numbers. So if I add, for example, one odd number here, 55, and one label here, for example, F, we see that this new value, that is added to my data list that is going to be later used to create my data in my series, is not an even number, it's an odd number. So when I run the code and go back to this filtering, we see that here we are having numbers from 10 to 50, but 55 is not being printed, which is this number in the original series. Why? Because when 55 is divided by 2, the remainder of this division, is it equal to 0? No, it's not equal to 0. So this statement is not true, therefore we are not going to have it. But how can filter based on odd numbers? If I want to filter based on odd numbers, simply we remove this equal and we assign this. Then we run the code one more time. So these are the values in the original series, 10 to 50 plus 55. And we would like to have the numbers that are divided by 2 and the remainder of their division is not equal to 0. It means that they are odd numbers. And when we are having this condition, we see that here it's not even numbers. We should write down odd numbers here. Sorry. So odd numbers. If I write it down, odd numbers in the series, it's the only one that is 55 that we see it here. So in this video, we learned how we can filter based on certain conditions that we can define ourselves. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about the apply function in Pandas. So it is commonly used to apply a function element-wise to a series or allowing an access in a data frame. Let me illustrate it with an example. So here we are creating our Pandas series. In order to do that, we are using the data list. So we are having 6 elements, 10, 20, 30, 40, 50, and 55. And here are the indices that we are having. For example, A, B, C, D, E, and F. We can call them indices, we can call them labels. For example, for label A, we are going to have the value 10 in our series. For label B, we're going to have 20, etc. until the end, when we are having label F for the value 55. Then we are going to create our series. So the name of my series is this name. This is the name of my series. Series is the name of my series. In order to create that, I'm going to call the series function from the pandas library. I'm assigning data in my series to be equal to the data list. So the right-hand side data is this data list, and this data is the reserved keyword in series. Then index is again the reserved keyword, and for indexing, I'm using the index labels list that we're having here. I would like it to be of integer data type, and its name is example series. So when I run this code, first of all, we are going to see the original series. So this is my original series. You see it here, original series. So label A value 10, label B value 20 until end, F with value 55, and we can see that the name is example series, the type is integer, exactly as we wanted. So the data type is integer, the name is example series. So now we can apply mathematical functions to our series through the apply function. We learned that the apply function in pandas is used to apply a function element-wise to a series. So here I would like to use the apply function for my series. And what is the function that I want to do? It's a square root that I'm using the NumPy library for that. So let me change the name of my series. So I would like it to be, for example, Reza 1. Okay. So here is my series now. It's easier to, I think, provide examples when we are dealing with a different series name. So now the name of my series is Reza 1. So I can use the apply function for my series that is called Reza 1 to perform some mathematical functions. And we know that for using mathematical functions, we need to use different functions in the NumPy library. This is why I'm importing the NumPy library as well. So I am calculating the square root of the elements in the Reza 1 series by using the apply function, and I'm using the NumPy library for the square root. So therefore, this apply function is helping me to have the element-wise operations. Okay, so when we see the output here, we are seeing that this being printed, applying mathematical functions. So this is applying mathematical functions exactly like that. Then we are applying square root function. So here we are having the square root of our elements. So for the label A, the square root is 3.16. So the original number is 10. Its square root is 3.16. The original element, the second original element is 20, and its square root is 4.47. Then for the label C, the square root is 5.47. So for label C, the square root of 30 is 5.47, etc. Until the end, we are writing down the square root of all these elements using the square root function, let's say sqrt from the NumPy library, using the apply function for my series that is called Reza1. Okay, now we can have the logarithm as well. So logarithm is called from the NumPy library using the apply function for the Reza1, and here is the natural logarithm for the elements being labeled from A to F. Then after that, we are having the exponential function from the NumPy library we are using it through the apply function for my series that is called Reza1. And for that also, we see that for example, first element, the exponential function is this one. For the last element is this one, for example. Okay. Then another thing that we can do for our series is to apply custom functions. So in order to apply custom functions, we can have the name of the series. We use the apply function, and then we are raising each element to the power of 2 using the lambda function. Okay, so each element of the Reza1 series is being raised to the power of 2 through the apply function here in this line. And also here in this line, we are printing a prefix value before printing each element in the series. So when we come here, we see that, for example, the double the value is this one. So the first element, sorry, this one is not to the power of 2. It is the x multiplied by 2. If we were having 2 stars, it was like we were raising the value to the power of 2. We are simply just multiplying it by 2. So if we were having 2 stars like this, we were raising it to the power of 2. So when I run the code, now we are raising it to the power of 2. So the first element is 10, 20, 30, 40, 50, 55. So when I run the code, here we see that the power of 2 is like the first one was 10, so now its power of 2 is 100. The second one was 20, now it's 400. The third one was 30, and now it's 900, etc. So this is how we can have a custom function to the power of 2. And if we wanted to multiply it by 2, we could have simply 1 star. Then we would like to have the prefix before the x being printed in the output. So when we were having the prefix, this is my prefix value. So you see that in the previous stages, we were not having any prefixes. But now here I'm having the prefix value. You see, this word value is my prefix. So we are applying a lambda function to convert to string with prefix value. And we are having for the label A value 10, B value 20, C value 30 until the end. And finally, it's nice to know that we can also apply conditional functions. For example, we can mark values as high if they are larger than 30. Otherwise, we are going to mention that, for example, they are low. So I'm using the lambda function from the to perform this condition for the elements of my series through the apply function, which help me to have the element-wise operations. Okay, so here I'm saying that if that element of my series called Reza1 is larger than 30, label it as high. Otherwise, label it as low, meaning that if the value of x is lower than or equal to 30, label it as low. So when I run this code and I come here, we see that the first 3, they are low. The last 3, they are high. So the first 3 elements, 10, 20, 30, they are labeled as low. 40, 50, 55, they are labeled as high. So if x is larger than 30, label it as high, else label it as low. And also we can apply a function that adds 5 if the value is even, otherwise subtract 3. So if the value is even, we're going to add 5 to that. Otherwise, it means that it's it's not an even number and it's an odd number, and we are going to reduce 3 from that in this case. Okay, so for example, the first element is 10. It's an even number. We are going to add 5 number to it, so it will be 15. 20, it's an even number, so it will be 25. 30, it's an even number, it will be 35. 40, it will be 45. 50, it will be 55. But 55, is it an even number? No. So 55, when it is divided by 2, the remainder of this division is not equal to 0, so it's not an even number. It goes to the else part. And here, 55 minus 3, it will be 52. So when I look at this example here, we will see that here we are having the applying a function that adds 5 if the value is even, otherwise subtract 3. So the first element was 10, now it's 15. The second element was 15, was 20, now it's 25. The third element was 30, now it's 35. The fourth element was 40, now it's 45, because they were all even. The fifth element, it was like 55. It was like 15, now it's 55 because it was even and we added 5 to it. And finally, the last element was 55, and it was not an even number, so it was an odd number. Therefore, we subtracted 3 values from it, and it has become 52 now. So in this video, we learned that we can use the apply function to apply for example, the element-wise operations. First of all, we were having the data list and the labels. We created a series from this data list and the labels. Then we learned that through the apply function for our series, we can perform certain mathematical operations, for example, square root, logarithm, and exponential function. Then we learned that we can apply custom functions. For example, we can raise the elements to the power of 2. We can have the prefix being printed. We can apply conditional statements. For example, if the elements are larger than 30, print high, otherwise print the message low. Or for example, here, if it's an even number, add 5 value to it, otherwise subtract 3 value to it. So all of them are, all of this is possible. And we saw that in this example, we can do that. And finally, here we are going to have the user-defined function here. So we can have a function called custom function, and we are going to, when this function is called with one argument x, we are going to check if x is divided by 2, the remainder of this division equals 0. If this is true, it is going to multiply that x by 3. Otherwise, it is going to add 7 to that x variable. And whenever we want to call this function for the elements in my series, we are going to write down the name of the series, which is Reza1. Then through the apply function, we can call this custom function. And this custom function is basically going to perform this mathematical operation over all the elements of Reza1. Therefore, the first element, is it an for example, even number, okay, multiplied by 3 up until the end. So we see that here, for example, we are having the first element was 10, and it is now multiplied by 3, so it's 30 because it was an even number. It happens with all the elements because all of them except the last one are even numbers, so they are multiplied by 3. But the last element was 55, and it was an odd number, and we said that if it's not an even number, add 7 to that variable. So we see that here we are having number 62, which is 55, the original element, plus 7, so it has become 62. So we can also have a user-defined function for our series called Reza1 through apply function. Thank you for watching. Welcome back. In today's video, we're going to work with the map function for this series. So here is my data list containing 5 elements and the labels. And we are creating our series called Reza2. And in order to create that, I'm calling the series function from the Pandas library. I assigned the data of this series to be equal to this data list, and the index of this series to be equal to index labels. And then I would like it to be of integer type, and the name is example series. So now I would like to perform some operations using the map function. The first thing that I would like to do is to convert these numbers that I created in my series, that I initialized for my series. I would like to convert them to strings. And in order to do that, I simply write down the name of my series, which is called Reza2. Then using the map function, I write down str in parentheses, and we see that here in the output, we are having the conversion of numbers to strings. Also, you are here again seeing numbers, but their data type is not integers anymore. They are of type object. It means that they are converted to a string. So in order to convert them to a string, we use the function map, and then for our series called Reza2. And then we can apply a function that labels values based on a condition. For example, here for the Reza2 series, I'm using the function called map, and because I'm defining a simple function, I simply use the lambda keyword to create my function here. So I would say if the value of the element in my Reza2 series is larger than 30, label it as high. Otherwise, label it as low. So these are the numbers 10 to 50. And for example, if 10 is larger than 30, label it as high. Is it larger than 30? No, 10 is not larger than 30. Therefore, we are going to fall into the else part, and we are going to label it as low. The same happens with the 20 and 30. So both of them are not larger than 30. So we are going to label it as low. Then we are having 40 and 50 that are larger than 30, and we are going to label them as high. So when we come and see the result, we see that the first three elements are low, labeled low, and the last two ones are labeled high. Then we would like to apply some mathematical transformation. For example, here we are having the square of each element. For my series called Reza2, I use the map function to have the square of each element. So when I run the code, I come here and see the first element was 10. Its square is 100, so 100 is there. My second element is 20, and the square of 20 is 400. 400 is there. My third element was 30. The square of 30 was 900, etc. until the end. So we learned here that we can also apply some mathematical operations. For example, having the raised to the power of 2. And also, we can apply a function that categorize values into ranges. For example, for my series Reza2, I use the map function to label it as a small if the value is lower than 20, and if the value is lower than 40, I'm going to label it as medium. Otherwise, I'm going to label it as large. So we see that the first element is a small because the first element is number 10. The second and third elements that are 20 and 30 are labeled medium, and the last two elements are labeled large. Why? Because the first element is 10. 10 is lower than 20, yes. So label it as a small. Then we were having the second and third elements because they were lower than 40, and because 20 is not lower than 20. If it was like 20 lower than or equal to 20, yes, we would have labeled it as a small. but 20 and 30, both of them fall into the medium part. Why? Because they are lower than 40. And the rest of them, like the 40 and 50, they do not fall into this range as well, so they are falling in the large part that they are labeled as large, as we see here. Also, we can use map function with a dictionary for value replacement. So here I'm having, for example, a dictionary, and in dictionary we are having key value pairs. So the keys are 10, 20, 30, 40, and 50, and the values are these strings 10, 20, 30, 40, and 50. Okay. Then here in the output, we are having the series called Reza 2 using the map function, and we are in parentheses calling the mapping dictionary that we just declared. So here in the output, we see that these numbers 10, 20, 30, 40, and 50. So these numbers that are in string, they are being labeled from A to E. So we are basically replacing values using a dictionary because the values were numeric here, but we see here they are strings and we replace them using a dictionary. So it's possible to replace values using a dictionary. How? We write down the name of the series, then the map function, and in parentheses we write down the name of our dictionary, and it is going to automatically replace the values. Then we are willing to handle missing keys in dictionary mapping. And for example, here we are having a dictionary called mapping dictionary with missing. Okay, so it has two elements, two keys, let's say 10 and 30, and two values 10 and 30 that are a string. Then we are using a lambda function for my Reza 2 series through the map function, and we are saying that, okay, get the value of x from this dictionary, which is called merging dictionary with missing. So basically it is this dictionary, get the value of x. Otherwise, if there is no value, assign unknown. And when we come and see, we see that the first one is 10, the third one is 30, but the other ones are unknown. But how is that possible? So my series is like having these values 10, 20, 30, 40, and 50. Okay. And my dictionary is having the keys of 10 and 30. Okay, so 10 and 30, you see it here. So it says that for the value, for the key 10, replace its value with 10, which is a string. And then for 30, replace it with 30, which is a string now. So we are here using a function to get the values from this mapping dictionary with missing. And if there is the value there, return the value, which is 10 and 30. Otherwise, return unknown for my series called Reza 2. Okay, for this series, we see that we are having 10, 20, 30, 40, 50, but here we are only having 10 and 30. So these two are there. So for these two, it is going to get the value of the x, which is 10 and 30. For 20, 40, and 50, it is not going to get that. Why? Because there is no value for that. Therefore, it is going to return unknown. So exactly as we see here, 10 and 30, they were there. So it is there. And then the unknowns are also there, as we can see it here. And finally, here it is possible to handle non-values gracefully. For example, we are having a series here that is containing these elements, and the labels are from the index labels list. So these are the labels A, B, C, D, E, and these are the numbers 10, 20, none, 40, and 50. Okay, so there is one missing value there, and we are going to handle them using the map. So I use the map function for this series that is called series with none. Then we are going to say if there is a value there, get that X, otherwise report the missing string. So here it is going to get the value 10, 20, 40, and 50. But for the C, it has no value, so it is writing down the missing message. Why for element C, for label C, there is no, because this one is label A, this one is label B, this one is label C. And for C, we have the missing value. So here in the function, we are checking, okay, if there is any value for the X, return it. Otherwise, report the missing string. So we see that here, because there is nothing there, we are reporting the missing string. So in this video, we learned how to work with the map function for our series. First of all, we learned how to convert our numbers into strings. We applied the conditional for the series. Here we raise the series to the power of 2. Here we were having like another conditional example where categorizing values were discussed. Here we are replacing values using a dictionary. Here we are having a dictionary that is having 2 elements, while in our series we are having 5 elements, so the missing elements are detected there. And also here we learned that if there is any value in for certain labels, we are going to return them. Otherwise, if there is not something there, we are going to write down the missing string label there. Thank you for watching. Hello everyone, welcome back. Here is a table to compare the map function and apply function for our series. So here we see that in terms of scope, maps are element-wise transformations, and apply, when we are using the apply function, we are having the flexible transformations. And the maps are only applicable to series, while the apply function can be applied to series and data frames as well. So here we see that for maps, we can apply a function to each element. And while we are having the apply function, where we can use it to apply a function to elements, to rows or columns. So it's more flexible as we see this apply function. Then for the map function, we know that they can support dictionary mapping, while using the apply function, it's not possible to support dictionaries. And with respect to data frames, I would say the maps are not working with data frames, and they only work with series. While using the apply, we can work with data frames as well. And is it possible to do the row-wise operations using maps? No, they cannot apply functions like row-wise stuff. But for the apply function, we can apply them to row-wise with axis equals 1. And for the maps, the performance is faster for simple transformations. But for the apply function, they are slightly slower but more powerful. So in this video, we compare the maps and apply functions, because in the previous videos we were having some coding exercises with apply function, and we were having some coding exercises with map function, but it was not tangible to see their differences. So we see that we can use the apply function for series and data frames, while using maps we can only apply them to series. And for doing the functions, having the functions to elements, we can use the apply and map functions, both of them. However, we can further use the apply function for rows and columns, while the map function support dictionary mapping. In the apply function, we don't have the dictionary mapping. Okay, so the apply functions are also good for the data frame, but for the map function, we cannot apply them to data frame, and they only are used for series. So, and they are typically faster, but apply functions are a bit slower. So this was a good comparison of apply and map functions. So now we know their differences, and we know that if we are working with a data frame, we need to use the apply function. Okay, if we want to have a function for rows and columns, we are going to use the apply function. Okay, but if we would like to only work with series, or we would like to have a support for dictionary, or we would like it to be faster, we are going to use the map function. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to learn how to create data frames from dictionaries, lists, and NumPy arrays. So first of all, let us start with creating data frame from a dictionary. Here is my dictionary. The dictionary is called data_dictionary. There are three parts in the dictionary, or let's say three categories: name, age, and city. In the name part, we're having four names: Alice, Bob, Charlie, and David. In the age part, we are having four ages: 25, 30, 35, and 40. And in the city, we are having New York, Los Angeles, Chicago, and Houston. In order to convert this dictionary of mine into a data frame, we write down a name for our data frame that I called df_dictionary, or we can call it my first data frame. For example, this is the name that I choose, my first data frame. And here, let me, my first data frame. This way it would be easier to trace it. So I name my data frame to be my first data frame. In order to create it from this dictionary, I write down the data frame function. I call the data frame function from the Pandas library, and data in my data frame equals the data_dictionary, which is the name of my dictionary. Okay, so dictionary one, if I call it, it's easier to understand. So the data in the data frame that is called from Pandas library. So the data that we want to have for my first data frame, in order to create it, I call the data frame function from the Pandas library, and this data equals dictionary one, which is this dictionary. Okay, that's it. We created our data frame. Now we print this data frame. So when we run this code, we see that this is the data frame. Okay, so we are having the columns. So these are the numbers 0, 1, 2, 3. So they are also indices. Here is the column for the names: Alice, Bob, Charlie, David. These are the age. And these are the cities: New York, Los Angeles, Chicago, Houston. So it means that the first person with index 0 is Alice, with 25 years old, from New York. The third person is with index 2, Charlie, age is 35, from Chicago, for example. So this is how I created my data frame from an existing dictionary. But now I would like to create my data frame from a list of lists. Okay, so a list of lists. So this is my data list, and it has four lists inside of it. The first one is Alice, 25 years old, from New York. The second one is Bob, 30 years old, from Los Angeles. The third one is Charlie, 35 years old, from Chicago. And the fourth one is David from Houston, with 40 years old. Now these are the lists inside my list. Okay. And now I need to define the column names as well. So in order to have names for my column, I'm having a list called column lists, and inside that we are having three strings that are name, age, and city. And now I would like to create my data frame from these two lists, the column list and these data list. Okay, so I call the data frame function from the Pandas library again. and then data equals data underscore list, which is this one. So the data in my data frame equals data underscore list, which is this one, and column equals the column list. So the column that I would like to have equals this column. And then I print this data frame list. So this is the data frame from the list. Again, we are having the columns, and here are the names, ages, and cities. Okay, so first of all, because we are creating a data frame from a list of lists, we don't have any name for our columns. Okay, but here in the dictionary, we're having name, age, and city that we used for the columns. But here, because we don't have that, we need to, after having the data list, we need to create the column list as well. So the data list is assigned to the data of the data frame, and the column list is assigned to the column titles of my data frame that is called df underscore list, and then I was printing it in the output. Finally, we would like to create a data frame from a NumPy array. In order to do that, I start having a NumPy array first of all. So the NumPy array is called data underscore array. We call the array function from the NumPy library, and this is my NumPy array. Okay, Alice 25 New York, Bob 30 Los Angeles, Charlie 35 Chicago, and David 40 Houston. So this is my NumPy library, NumPy array, sorry. Now I would like to create my data frame from this NumPy array. In order to do that, I name it first of all, df underscore array. I name it this. I call the data frame function from the Pandas library data equals data underscore array, and column equals name, age, and city. Okay, I could say columns equals columns list, or I can directly introduce them here. So name, age, and city. Then I print the data frame array here in the output. So when I run the code, I see the same data frame here in the output. So in this video, we learned how to create data frame from dictionaries, lists, and NumPy arrays. First, we learned how to do that in dictionaries. So dictionary one is declared. We use this dictionary to convert it to a data frame. We don't need to do any column titling here because we are already having name, age, and city here. Then we're having a list of lists. So data list is a list of 4 lists. And then I use this along with the column list to create my own data frame. And finally, I used a NumPy array to create my data frame called df underscore array. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about data frame. So a data frame in Pandas is a two-dimensional labeled data structure, as you see here, for example, that can be like a table, like this example, or it can be on a spreadsheet. So you see that we are having, for example, column names. This is the first row, second row, third row. Then we are having different columns here. So it consists, because it's a two-dimensional data structure, it consists of rows and columns, where each column is a pandas series. So this one is a pandas series. Then the column name, the column age is another pandas series. The last column salary is another pandas series. So each column is a pandas series, meaning that it's a one-dimensional array. Okay. Then each row represents an observation. Okay. You see that, for example, this first row index is 0. The name of the person is Alice. Then the age is 25. The salary is 50,000. It's an observation. It can have different data types like integer, floats, a string, and it provides powerful functionality for data manipulation, filtering, and transformation. So in the later videos, we are going to learn how to work with data frame in Pandas. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about how to explore a data frame. So we are going to learn how to use the head function, the info function, describe function, shape, and the type. So first of all, this is my dictionary called data. There are name, age, salary, and city, and in each one of them, for example, in the name part, we are having Alice, Bob, Charlie, David, and Eve. Then for the age, we are having 25, 30, 35, 40, and 28. For salaries, we are having 50K, 60K, 70K, 80K, and 55K. And for cities, we are having New York, Los Angeles, Chicago, Houston, and San Francisco. Now, this is my dictionary that I would like to create a data frame from. In order to do that, first of all, I call the data frame function from the Pandas library, and I put the name of the dictionary inside parentheses, and the name of my data frame is data frame 1. Okay, so it is going to create a data frame like Alice has 25 years old with this salary from New York. Bob has 30 years old with 60K salary from Los Angeles. So when I run the code, first of all, we see that the original data frame is being printed because I am printing it here. Okay, so we are having this data frame. There are 5 rows. So you see this is the first row, second row, third row, fourth row, and fifth row, and we are having different columns like name, age, salary, and city. So it's a data frame because it's like a two-dimensional table where we store our data. Each column is like a series in a pandas series, and each row is like an observation, like Alice, 25 years old, salary is this one, and this person is from New York. Okay, so let us now work with the head function. In order to view only a few rows from the full data frame, we can use the head function. Head function is going to help us to see, for example, the first 3 rows. So I call the head function for the data frame 1, which is my data frame, and I write down number 3 in parentheses. It is going to show me the first 3 rows of my data frame. So my data frame has 5 rows, but here, as you see, only the first 3 rows are shown here when I use the head function. Okay, so head function is going to help me to see only a few rows among the all rows. For example, I can have the head of 2. So when I run, I see only 2 rows. When I have, for example, number 4, I see 4 rows here, as you see. So 4 rows. It is possible to see here in the output. So depending on how many rows we are looking for, we can have the head function to help us to print certain rows of our data frame. Okay. Then, in order to get the information of our data frame, we can call the info function for the name of the data frame. So data frame 1 is the name of my data frame, dot info. So this is going to give me this information. Okay, this is going to give me this information about my data frame. Okay, for example, it says it has 5 entries from 0 to 4. So they are labeled from 0 to 4, as you see here. And we are having, these are the data that are indexing from 0. And then these are the columns, for example, and the type of each column. For example, we are having the object, integer, and the object. Okay, so the first one and the last one, they are the data type is objects because we are having like in New York, and the name is like Alice, Bob, Charlie. Then the other 2 ones, age and salary, they are of data type integer. So it says that the memory usage is like 292 bytes. So this is the information for the data type. We can use the info function to have that. Then we can have the descriptive statistics for numerical columns. What does it mean? So let me print it and you will see. So we call the describe function for the data frame 1. And here we see some stuff is being printed here in the output. Okay. So this is the descriptive statistics about my data frame. So it is having the count, which means that this is the number of non-null entries in the column or series. So there are uh, five rows that we are having. So we are having the entries there, so nothing is missing because we were having 5 rows and we are having the number 5 here. So for age we are having 5 numbers being entered. For salary we are having 5 numbers being entered, and the full data frame has 5 rows, meaning that we are having no missing entries. Then we are having the mean, which is the average of the age. And then we are having the salary mean, which is so for 63,000 is the salary, that is the average salary in our data frame, and the average of the age is approximately 31.5 years old. Then we are having the standard deviation being calculated as to be 5.94 for the age and to be 7,041 approximately for the salary. Then we are having the minimum value. For the salary it is 50K, for the age it's 25. The maximum value we are having here 40 for the age and 80K for the salary. Then we are having 25%, 50%, and 75%. Basically, for example, the 25%, so basically this 25% means that the 25 percentile, or we can also call them the first quartile, this is what we call it, and this means that 25% of the data falls below this value. So 25% of the data falls below 28 years old and 55,000 for the salary. Okay. Then we are having the 50, or also known as the median, and this is the middle value of the data set. So this is the middle value for the data set of age, which is 30, and 60,000. This is the middle value of the salary, where half of the data falls below this value and half of it falls above this value. Okay, so we are having the salary here, which is 60,000. So this is the median for the salary, and 30 years old for the age is the median of this category age. Okay, then we are having the 75%, which means that 70% of the data falls below this value. For the age, it is 35, and for the salary, it is 70,000. So these are the descriptive statistics that can be useful in our work while working with our data frame. And in order to have them, we learned that we can call the describe function in order to have this information about our data frame. And it's very useful because when we are having a very, very large data frame, like for example, imagine that you're having 2000 rows. So it has a lot of numbers and probably you're missing some numbers. When you know that you're having 2000 rows, you see that, okay, the count is not 2000 for the age. For example, it is 1982, meaning that you are missing 18 values for age. Okay, and you need to think about that as well, about cleaning that, or maybe removing from your data frame, or maybe put the median, put the mean or average of your ages there, so it does not disturb your data and it will not give you a bad result in the output. Okay, so this is something that we are going to work with actually. When we are working with data frames, it's important to clean your data first and then start analyzing your data. And when you're having like 2000 rows, you can check, okay, what's the average, what's the median, what's the standard deviation, is it high, is it low, what's the minimum, what's the maximum, and based off each one of these rows you can make uh, some analytics over your data frame. So in order to have that, you can have the describe function. Then in order to check the data frame shape, like the rows and columns, we write down the name of the data frame dot shape, and this is going to give us this in the output, the data frame shape. We are having 5 rows and 4 columns. So you see that these are very good methods in order to have a good summary of your data frame. So how many rows do I have? How many columns do I have? What's the median? What's the standard deviation? So based on all of these things, you can have a very good understanding of your data frame. Okay, what if I want to see only the first, third row only, etc. And finally, we are going to use the D types for my data frame to see the data of to see each column data type for the name and for the city, its object, and for the age and salary, you see that it's integer. So in this video, first of all, we learned how to create a data frame from the dictionary called data. Then we learned how to create our data frame. Okay, so we used that dictionary that we created here to create our data frame. Then we print it first. And then we learned that we can use the head function in order to access and see only the first few rows. For example, here we are seeing the first 3 rows only. Then we learned how to have some general information about our data type using the info function. We learned about the describe function, which is going to give us descriptive statistics. Then learned how to find the number of rows and columns, and also checking the data type of each column. Thank you for watching. Hello everyone, welcome back. In this video, we are going to learn how to have access to data using the lock, ilock, and column selection for our data frame. First of all, let us create our data frame. This is my dictionary. There are 4 categories, let's say, name, age, salary, and city. In each one, you're seeing that there are some elements like Alice, Bob, Charlie, David, and Eve in the name. We're having 25, 30, 35, 40, and 28 for the age. We're having the salaries, 50K, 60K, 70K, 80K, and 55K. And we are having cities. It means that, for example, Alice is 25 years old, is earning 50,000, for example, US dollars, and this person is from New York. Okay, but I need to create my data frame from this dictionary. In order to do that, I call the data frame function from the Pandas library, and I put the name of my dictionary inside parentheses, and the name of my data frame is df. Okay, then I print the df, the data frame. So when I come down, I see that the original data frame is like this. So column name, age, salary, and city, and you see each column is like a series, a pandas series. Each row is like an observation, like Alice with the index 0. She has 25 years old with this much of salary from New York. Bob, 30 years old, 60K from Los Angeles, for example, etc. So this is the original data frame that we created. Now we would like to see how we can access data from this data frame. First of all, selecting a single column. In order to select a single column, we write down the name of the data frame df, and in square brackets, we're going to use the name of the column that we are looking for. For example, I'm looking for the column age. I write down age here. Okay. Then when I print this, so print the name of the data frame and then the name of the column in square brackets in quotes. So here we see that we are going to select the age column, and based on the age column, I'm seeing 25, 30, 35, 40, 28, exactly these numbers. And these are the indices. So it's from 0 to 4. And these are the ages from 25 to 28. Now, what if I want to have multiple columns? In order to have multiple columns, I'm writing down the name of the data frame. Then in square brackets, we are having name and salary. For example, I would like to have two columns, name and salary. Now here I see name and salary. So for the names, these are the names, these are the salaries. For example, I know Charlie gets 70K. Okay, so we are accessing the multiple columns at the same time from the df data frame, and we see that in the output because we are using the print function. And how can we access rows? Using the lock. Okay, so labeled base indexing, we call it. For example, here, in order to access the row where index is 2, so index 2, here is the index 2. I would like to access this one. How can we do that using the lock? We can have the name of the data frame, then dot lock, and in square brackets, we are having number 2. It is very simple. Now we see that we are accessing the row with index label 2 using the lock. So we see that all the information about Charlie is being printed here. So the name is Charlie, age is 35, salary is 70K, city is Chicago. Okay. So everything about Charlie is being printed here in this part. We are accessing this row with index label 2. Okay. Then we can also select specific rows and specific columns. So we can call the name of the data frame, then dot lock. Then we would like to have these rows from index 1 to 3, and only columns name and city. So I would like to have rows from 1 to 3, these 3 rows, okay? And only columns that are name and city. So name and city. So these 3 rows, these 2 columns, name and city. In order to see that, we see that here we are having only 3 rows from 1 to 3. So index from 1 to 3, we are having 1 to 3. The name Bob, Charlie, David, and city Los Angeles, Chicago, Houston. So now when I want to use my data, I know that Charlie comes from Chicago, David comes from Houston, and Bob comes from Los Angeles. Okay. So in order to select the specific rows, we write down the indices and then the columns that we are looking for. Okay. In order to access rows using ilock, meaning that position-based indexing. Okay, now I write down the name of my data frame, which is df.ilock, and the index 3, for example. It is going to select the 4th row for me. Index 3 is David, which is the 4th row. So the first row, second row, third row, and 4th row. So I'm calling the 4th row, which has the index 3, using the ilock for my data frame df. Okay. So this is being printed here in the output. The information about David is being printed. David 40 80K Houston, okay, using the ilock. Okay. We did that using lock as well. So this part, this one is the position based. Using the ilock, I am accessing the index 3, okay, using ilock. Here I was accessing using like the second row using the labels, okay, index label 2, and I was using the lock function. Then you can have the selecting of the first 3 rows and first 2 columns using ilock. Okay, so here is what we did here with the lock. We did it here. So for example, indices 1 to 3 for these 2 columns, and here for the ilock we need to write down the indices here. For the ilock, I would like to have the first 3 rows, so 0 1 2, and 3 is not included. And here I would like to have the first 2 columns, so 0 and 1, and I'm using the ilock function. So now here, as you see, the first 3 rows are there. So the first 3 rows are Alice, Bob, and Charlie. Alice, Bob, and Charlie, the first three rows from 0, 1, and 2. And name and age, so the first two columns, they are also their name and age. Okay. So we see that we can select specific rows and columns using alloc as well. So we can have access to a specific cell as well. It's possible. For example, if I want to know the salary of the person with index 2, which is Charlie, index 2, it's for Charlie, I can have the lock, index 2, and the salary. So it is going to go to my data frame df, looking for row 2, and the cell that corresponds to row 2 and the salary column is this number. 70,000 is being printed here in the output. Or I can have the ilike function where I write down the name of the index of the row, which is number 2 because 0, 1, and 2, and then the index of the column, so 0, 1, and 2. So this is going to lead to this row and this column, and they intersect at this 70,000 as we see here. So accessing the specific salary salary of Charlie using lock and using iloc. So in this video, we learned how to access data using the lock and iloc and column selection. We learned how to create our data frame, how to have access to a single column, multiple column, and how to access rows using the lock, and how to select, for example, multiple rows with specific columns. We learned to do the same things with iloc as well. So here we are selecting specific row. Here we are selecting specific rows and columns. And here we learned how we can have access to a specific cell using lock and iloc functions. Thank you for watching. Hello everyone, welcome to this video. In today's video, we would like to have the filtering data using certain conditions. So first of all, this is my dictionary, and from this dictionary, I need to create my data frame. So the dictionary name is data. 4 categories are there: name, age, salary, and department. And we are having the names here. So there are 5 entries: Alice, Bob, Charlie, David, Eva, and the ages are 25, 32, 23, 40, and 29. And these are the salaries: 50K, 60K, 45K, 80K, and 52K. And these are the departments like HR, IT, HR, finance, and IT. For example, it means that Alice is 25 years old with the salary of 50K, and this person works in the HR department, while Bob is 32 years old and he earns 60K annually, and he works in the department of IT. So now I would like to create my data frame. So the name of my data frame is df, and this data frame is created based on the data dictionary using the data frame function from the Pandas library. So first of all, we're going to print the data frame. So this is my data frame. I'm having a table with these columns, and these are my entries: first row, second row, third row, fourth row, and fifth row. Okay. For example, it says Charlie is 23 years old. He earns or she earns 45K, and this person is in the HR department. But now, how can we use conditions? Now, I would like to filter rows based on the age. I would like to only see people whose age is larger than 30. So I write down the name of my data frame. Then I would say for each element that is in the age column in my data frame df, and its value is larger than 30, print that for me. So this is assigned to filtered df1, and filtered df1 is being printed. So here is the output. So employees older than 30, we are seeing that we are having 2 employees, Bob and David. The rest are lower than 30. So you see this here. And these are the people, Bob and David, that are older than 30. So we learned that we can filter employees based on their age. Simply we write down to the values that are in age column in our data frame that is larger, that are larger than 30. And then if we want to, for example, filter based on the salary, for example, we would like to filter rows where salary is less than or equal to 50K. So everyone who earns less than 50K, we would like to have them in my output. So I would say the name of the data frame. Then I would say for all the values that are in the salary column from the data frame df, and the values must be lower than or equal to 50K. This is assigned to filter df2, and filter data frame 2 is being printed here. So we see that everyone who is earning at least it's everyone who is earning less than or equal to 50K. It is being printed here in the output. For example, Alice earns 50K exactly, and Charlie earns 45K. So only these two people in our data frame are earning less than 50K. The rest are earning more. So we filtered based on the salary here. Then we can also filter based on the department. So I would like to have only people who work in the IT department. So for every value that is in the column department from the data frame df, and if that string or value equals IT, okay, this keyword, assign them to filter data frame 3 and print it for me. So here when I look at this output, I see that all the people who work in the IT department are shown in this newly generated table. So I have Bob with index 1 and Eva with index 4. So Bob index was 1, Eva index was 4, and the information to Bob and Eva is being printed here in the output, and they both work in the IT department. So far, first of all, we created the data frame. Then we filtered based on the people who are older than 30, then filtered based on the salary lower than 50K, and then for employees who work in the IT department. Now, I would like to filter rows based on age again. So the age must be between 25 and 35. So if I want to do that, I simply write down for all the elements that are in the age column that are larger than or equal to 25 and lower than or equal to 35. This information needs to be assigned to filtered data frame 4, and we're going to print data frame 4 here. So in the output here, we see that people that are between 25 and 35 are these three people, Alice, Bob, and Eva. And they have 25, 32, and 29 years old. These are the salaries, and these are the departments. So now also we learned how to have the conditions with AND operator. Now let's say we would like to filter based on OR operator. For example, we would like to filter rows where salary is greater than 50K or the age is less than 25. So this is my criteria, either this condition or this condition. Either of them, if either of them is true, we're going to have the data. So either the salary must be larger than 50K or the age must be lower than 25. This is assigned to filter data frame 5, and we are printing it here in the output. So employees with salary more than 50K or age less than 25. So Bob is there. So certainly Bob is 32 years old and he is not lower than 25. Therefore, he must earn more than 50. So we see that he earns $60,000 annually. Then we are having Charlie, whose age is 23, which is lower than 25, so it satisfies at least one condition. So David, we are having with the age 40. 40, is it lower than 25? No, therefore we can conclude that his salary is larger than 50K. This is why he's there. So 80,000 is there. And then we are having the Eva, who is 29 years old and earns 52K. So now we see that we can filter data based on two different conditions using AND operator and OR operator. In order to have the AND operator, both conditions must be true. So we say that the person must be older than 25 and at the same time lower than 35. So both conditions must be true in order to have the outputs here. But when we are using the OR condition, we should be careful because at least one of the condition must be true. If at least one of the conditions is true, we are going to have the data. For example, here, Bob, he is not lower than 25. He's not younger than 25, but he earns more than this. So one condition is passed, therefore he is here. So this is one thing that we need to be careful about. Then we can filter where the name is not a specific person. For example, I would like to have all the names, but I don't want to have Alice. So I can filter out Alice. In order to do that, we say, okay, all the values that are in the column name from the df data frame, but the values in the column name should not be equal to Alice. So when I print this df6, we see that here all the employees information is there, but we don't have Alice here, so Alice is filtered out. Okay, so we can also filter out one person using this. And then we can have the filtering rows where department is either HR or IT. In order to do that, we are going to use isIn function. So I would say for all the values that are for all the data that are in the department column, and they should be either HR or IT. If they are either HR or IT, I would like to have them in the output. So I print df7. When I print df7, here we see that all the prints here that are people who are either in HR or IT. So we have Alice from HR and Charlie from HR, Bob and Eva from the IT department. So this is also how we can filter people who are in a specific department, either HR or IT. And you see that David, who works in finance, he's not there. And finally, we can filter rows where salary is not between 45K and is not 45K or 80K. So we are going to print this from the salary column. So every data that is in the salary column, and we are using the isIn function for 45K and 80K. So when I run the code, we see that here in the output, people who are having these two salaries, 45K and 80K, they are not being printed in the output. Okay, so here people who are having 45K like Charlie, okay, and David who has the 80K, they are not considered in the output. So we are kinda using the isIn in a way that the salaries that are not equal to 45K or 80K, and in order to do that, we simply need to have the tilde here so it can help us to have the output. So to illustrate it with another example, for example, here I mentioned that all the people who work in HR or IT, I would like to have them in the output, and I used isIn function. So everyone who works in HR and IT is being printed. But what if I want all the people that do not work in HR, in neither HR nor IT? In order to do that, I can simply use a tilde sign here, and then when I run the code, people who are working in another departments apart from HR and IT are being printed out in the output. Okay, so here I would like to have people who are not earning 45K or 80K. So I'm putting the tilde there. So if I remove this tilde, it means that I would like to print people who are earning either 45K or 80K. So in this video, we learned how to filter data using conditions. For example, where we are having a specific condition for age greater than 30, salary less than a certain amount, or people who work in a specific department. And we also learned how to access different data using different conditions, like when the age is between 25 and 35, when the salary is larger than certain amount, or the age is lower than certain age. And we learned how to exclude someone from the list, how to have the information about someone who works either in this department or this department. And we also learned how to not include people who are earning this much of salary annually. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to filter our data using query function. So here is my dictionary called data. There are 4 categories: name, age, salary, and department. And in the name, we are having Alice, Bob, Charlie, David, Eva. In the age, we are having 25, 32, 23, 40, and 29. In salary, we are having 50K, 60K, 45K, 80K, and 52K. And in department, we are having HR, IT, HR, finance, and IT. Here, we see that, for example, Alice is 25 years old. Is 25 years old with salary of 50K, and this person works in HR. Or Bob is 32 years old, earning 60K, and this person works in the IT department. So we create our data frame using the data frame function from the Pandas library from the data dictionary, and we call the data frame to be df. First of all, we print df in the output. So this is my data frame. We see it here. We see that we are having different columns: name, age, salary, and department. We are having different rows: Alice, Bob, Charlie, David, and the information of them uh, is being printed here. For example, David is 40 years old. He earns 80K annually, and he works in the finance department. Okay. Now I would like to filter data based on query. In order to do that, I write down the query function from the for the data frame df, and the condition is age to be larger than 30. So age is exactly one of the column. So this is the name of my column. Okay. So I would say for every values that are in the age column and they are larger than 30, print it for me. Okay. So we are using the query function to do this, and we are using the data in the data frame df, and we assign the output in the filter df1, and we print the df1 here. So when we print the df1, we see that here everyone who is older than 30 is being printed here in the output. So we are having 2 rows. So Alice is not older than 30, so this person is not in there. Charlie is not there, and Eva is not there, but Bob and David, they are both there because they are older than 30 years old. Then we are having the filtering based on the salary. We would like to filter people who are earning less than 50K annually. So we write down the query function again for the df data frame, and we mention that salary is lower than or equal to 50K. So again, this is the name of my column. It is very important to know that exactly it should be like the name of my column. Otherwise, we are going to have errors. And for every people that are in the data frame whose salary is lower than 50K, we are going to have them. We are using the query function to do that. So when I see the output, we see that people who are having less than this much of salary, they are being printed here in the output, either 50K or lower than that. So Alice and Charlie, both of them are being printed here in the output. Then we would like to have people whose department is IT. So again, I use the query function for the data frame df, and I assign department to be equal to IT, and it is assigned to filter data frame tree, and we are printing filter data frame tree in the output. So people who work in the IT department, they are named Bob and Eva, and you see that the department is IT here. Then we're going to filter people based on their age. So for people who are between 25 and 35, we call the query function for the data frame df, and we write down, okay, age must be lower than or equal to 35 and must be larger than or equal to 25. So when we are having this condition, we see that here in the output, everyone in my data frame who is in this range is being printed. For example, Alice, Bob, and Eva, they are all between 25 and 35 years old. Then the next condition is to, for example, now we would like to filter rows where salary is greater than 50K or the age is less than 25. So we write down again the query function. For the df data frame, we mention salary larger than 50K or age is lower than 25. So either this condition must be true or this condition. Okay. So when I have that, we see that here we are having this in the output. So Bob, he is not younger than 25. He is 32, but he earns more than 50. This is why this person is there. And Charlie, she is not earning more than 50K, but she is younger than 25. This is why we are having Charlie. The same goes for the David. David is earning more than 50K, and Eva is earning more than 50K. This is why we are having Eva as well in the output. Okay, so next we would like to have Alice. We would like not to have Alice, in fact. So I would like to filter rows where name is not Alice. So I would like to have the list of my employees that are there. Everybody is there, but people whose name is Alice, I don't want them to be there. In order to do that, I write down query. The name of my column is name is not equal, okay, is not equal to Alice. That's it. And we see that people are being printed here except for those whose name is Alice. And this is my data frame is having a few rows. Maybe we are having a very large data frame with 2000 people there, so we can simply filter people whose names are Alice, for example, or we can filter people whose salaries are less than a certain amount. So it is very good to have a structured data frame in the output when we are using these queries. So we see that everybody is being printed here except for Alice. Then we are having the department. We are filtering rows where the department is either HR or IT. So I would like to find people who work in HR or IT department, either this one or this one. So I call the query function for my df data frame, and I mention the name of my column. So I would say for everyone whose department is in HR or IT. Okay, this is going to help me to access people who work in either HR or IT. So this is why I write down the name of my column for the department, and then I mention in HR or IT. Okay, I write the query using the data frame. So people who work in IT or HR, we see that they are Alice, Bob, Charlie, and Eva. Charlie and Alice, they are both in HR. Bob and Eva, they're both in IT. Then, in order to have a query for those whose salary is neither equal to this number nor to this number. So I write the query for the data frame df, and the name of my column is salary. So I say salary not in, and it means that salary is not equal to this number 45K, and salary is not equal to 80K. So people who whose salary are not 45K or 80K, they are going to be printed in the output. So we see that here we are having only 3 people because Charlie and David are being removed from the last table because they are having 80,000 salary or 45 salary. So we don't want them because we mentioned we want everyone whose salary is not equal to neither 45 nor 80,000. Okay, so this is how also we are doing this here. So in this video, we learned how to filter our data using the query. So we had a dictionary, first of all, here. Then we converted that dictionary into a data frame. We learned how to filter rows based on a single condition, for example, the age, then the salary, then department, then the age between a range to be in a range. And when we were having two conditions with or operator, so either salary must be larger than 50K or age must be lower than 25, and we were having this, for example, when Rose name is not equal to Alice, so we will filtering people whose name were not Alice. We learned how to, filtering rows where the department is either HR2 or IT, so we could find people who are either in HR or IT. And also we will filtering rows where salary is not equal to 45K and 80K. Thank you for watching. Hello everyone, welcome back. In this video, we would like to learn how to handle missing data. In order to handle missing data, we are going to use isNA, dropNA, and fillNA functions. So first of all, we are having a dictionary called data. There are 4 categories: name, age, salary, and department. And for the names, we are having Alice, Bob, Charlie, David, and Eva. For the age, we are having 25, none, 23, 40, and 29. So we see that one missing data is there for the Bob's age. And for the salary, we are having 50K, 60K, none, 80K, and 52K. So the third one is a missing value. And also for the department, we are having HR, IT, HR none, and IT. So here we don't know the department of David. Here we don't know the salary of Charlie, and we don't know the age of Bob. So there are 3 missing values. First of all, we need to create our data frame. In order to create that, we call the data frame function from the Pandas library. And in parentheses, we write down the data name because this is the dictionary that we are having, and we would like to create a data frame from this data dictionary. So call the data frame function for the data dictionary using the pandas library, and the name of my data frame is df. So I print here the original data frame, and this is the original data frame. So we are having these 4 columns: name, age, salary, and department. These are each row an observation. For example, the first row is the observation of Alice information, age, salary, and department. So for Bob, we were having the missing data for the age. For Charlie, we were having the missing data for salary. And for David, we were having the missing data for the department, and we see it here. So all the information is here, okay? Now we would like to work with the missing data, missing values, let's say. In order to do that, first of all, we are going to check for missing values using isNA function. So using isNA function for the data frame called df, we are assigning it to missing values, and we are going to have true in the output, true in the data frame where we have missing values, false in the data frame where we have actual values. Okay, so isNA is going to check if there is a missing value or not. If there is a missing value, it is going to return true. If there is not a missing value, it is going to return false. We are assigning it to these missing values, and missing values is being printed here in the output. So you see here, we are having the data frame that has many falses and 3 trues. 1, 2, and 3. Why? So this part is the age of the Bob with index 1. So with index 1, Bob, the age is none. So is a missing value in this cell? Yes, there is a missing value, therefore this is true. Is a missing value in this part? No, we know the exact salary, so 50K. So we see it's false because we know the exact value and it's not a missing data. So the missing data in the original data frame are being shown as true in the output here for us. So is and a is going to help us to have a data frame, the missing values in data frame to be true so we can trace them. Then we're going to use the drop NA function for our data frame df, and we are going to give it name to have df underscore dropped underscore any, and it is going to drop rows with any missing value. So when I see the output, here is my output. Okay, so we are dropping the rows with missing values. So here Bob, Charlie, and David, they were having some missing values. We dropped them and we don't have them here in the output. So we are working only here now with the rows that they have all the values and all the data. But you see that here we were having missing value, here we were having missing value, here we were having missing value, and these rows with missing values are dropped. Okay, so only Alice and Eva, whose information was complete, are reported here. So this is about drop NA. So we're going to drop any missing values. Then we would like to fill missing values with a specific value. For example, if we see any missing value in the age column, I would like to fill it with number 30. Any missing value in the salary column, I would like to fill it with 50K. Any missing value in the department, I would like to fill it with unknown. So I use the fill NA function for my data frame df and assign these values to my missing data. So when I look at the output here, we see that Bob's age was a missing value here. Okay, but here it is 30 because we mentioned that we would like to assign age to be 30 if there is any missing value. For Charlie's salary, we were having a missing value. You see here it was a missing value, but we are replacing it with 50K, as you see here, because we mentioned if there is any missing value in the salary column, 50K should be there. And finally, for the department, we are having unknown here. Why? Because it was a missing value for David. It was a missing value here, and we decided to have the department to be equal to unknown if there is any missing value in that cell. So this function fill NA is going to help us to fill the missing values with a specific value. But there is something else that we can do to fill missing values. For example, we can have the missing values being filled with the average of the column. For example, here, and let me show you first the result. Bob's age was a missing value. So I get the column average, these values, so 29, 40, 23, and 25. I compute their average and put the average in the Bob's age. Okay, I do the same with the Charlie's salary. So it's a missing value. I compute the average of the salary column and I put the average there. And of course, for the department, we can't do that. I keep it to be none. So in order to do that, here we are calculating the mean. So I first of all I first of all make a copy of the original data frame to the df underscore filled mean. So this is my new data frame. And there I would say for the column age, fill the age with the mean of the age column. Okay, so we are going to calculate the mean of this column and fill it for the missing values in the age. Okay, so here again I do the same. For the salary column, I am calculating the mean of that column and fill it there. Okay, so this is how it is done here actually. So this is how the column mean is calculated and the output is assigned to Bob's age here. Okay, so now we learned how to fill missing values with the column mean. So first of all, we got, because we don't want to modify the original data frame, we want to keep it there, we make a copy and the name of the copy is this. Then we work with the age and salary column. We calculate the mean, or let's say the average of these two columns, and we are going to fill the mean, the missing values with the mean of these two columns. Okay. The next thing that we can do is to have the forward fill. Forward fill means the following. So here, Bob's age was missing. Okay, forward fill means that I fill it with the previous value. Okay, so the previous person age was 25, I put the 25 here. So here the Charlie's salary was missing, so I'm putting the previous person's salary in the Charlie's one. And the David department was being missed, so I was putting the HR, which is the department of the previous person, for David as well. Okay, so this is what we call forward fill. In order to do that, we again call the fill NA function for the data frame. And in parentheses, we mention method equals f fill, meaning forward fill. It is going to propagate the last valid value forward. Okay. Then we are going to have the backward fill as well. So we can propagate the next valid value backward. Okay. It means that we are going to have, for example, the Bob's age was missing. I'm assigning the next person's age for the Bob. So the Charlie's salary was missing. I'm assigning the Charlie's the next person's salary for Charlie's salary. Okay. And the David department was missing, so I'm assigning the next person's department to be for the David department. Okay, so this is how we can do it. Next person's age, next person's salary, next person's department. So this is what is called to be backward fill, propagating the next valid value backward. In order to do that, we mentioned we call the fill NA function for the df data frame. In parentheses, we are having method to be equal to b fill, meaning that backfill, and that's it. It is going to do the backfill for us. So in this video, we learned how to handle missing data. So when we are going to have missing data, there are different methods to approach it. And in this video, we learned 3 methods to deal with the missing data. First of all, we use the isNA function, then drop NA and fill NA. In particular, first of all, we learned how to convert our dictionary to a data frame. We learned how to find and place the missing data by using the isNA function. It is going to return true wherever it is going to find the missing values. Then we have the drop NA function, meaning that it is going to help us to drop the rows with any missing values, either it's a salary, department, or age, etc. And we learned how to fill the missing values with specific values here using the fill NA function and the value in parentheses. We learned how to fill the missing values with the mean of the column. So here we were again using the fill NA function, but we were also calling the mean function. And then here we learned the forward field propagating the last valid value forward, and the backward field which was propagating the next value backward. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to learn how to rename columns. First of all, I'm having my dictionary called data. There are 4 categories here: name, age, salary, and department. For example, for the names, we're having Alice, Bob, Charlie, David, Eva. And for the age, we're having 25, 32, 23, 40, and 29. For salary, we are having 50K, 60K, 45K, 80K, and 52K. For the department also, we are having HR, IT, HR, finance, and HR. So it means that, for example, the first person whose name is Alice is 25 years old with this much of salary, 50K, and works in the HR department. However, Bob is 32 years old with 60K salary, who works in the IT department. Okay, so this is my dictionary. Now I would like to create my data frame, from the dictionary. So I'm creating a data frame from the data dictionary. So I call the data frame function from the Pandas library, and I called my data frame df. First of all, I print my data frame. So this is my data frame again. So this is the columns. These are the columns: name, age, salary, department, and these are the rows. So 1, 2, 3, 4, and 5 rows are there. So each row is an observation. For example, Alice information is in the first row. However, David information is in the 4th row. He is 40 years old with 80K of income, and he works in the finance department, for example. So we would like to rename a single column. How can we do that? So in order to do that, we call the rename function for the data frame df. Because we called it df, it can be anything. And then we mentioned that in parentheses columns, that and then we open the brackets. Okay, so we mention columns and then we open the brackets. First of all, we're going to write down the current name of the column that we already have in our data frame. So the first one is salary. So we would like to change the salary column name, and we already have the salary there. Okay, and I would like to change it to be annual salary. So the first word that we're going to write there is the current name of the column. And the second one after the column is the name that we're going to give to this column, which is annual salary. So I would like to change salary to annual salary. Okay, so we use the rename function to do that. And then we assign the data frame to df renamed one, and we print this one. So here is the original one, here is the df1. So we see that here the column salary is called salary. Here it is annual salary. So we renamed one column here. If I wanted to rename the column age, for example, here, I would have written age here, age, and then instead of having the annual salary, what do we want to call this column? I would say years old, for example. So I run the code. We see that here, this is the column's name, which is age, and here it is years old. So we are mentioning that we are changing and renaming this column's name. Okay. So this is how we can, first of all, rename a single column. However, if we want to rename multiple columns, how can we do that? In order to do that, we again call the rename function for the df data frame. Then for the columns, we are going to assign name to be employee name separated by a comma, then department to be depth. Okay, so there are 2 columns that we would like to rename. First, the column name, which is the first column, then the column department, which is here. Okay, and these two are separated by a comma. You see? So name, I would like it to be employee name separated by a colon. Department, I want to be depth separated by comma. Okay, we are using the columns and then the brackets. Okay, and we are using the rename function for the df data frame. We call it df rename2, and we are simply printing it out. So here, when I have the multiple rename, we see that here department was there and now it's depth. And let me run the code one more time. So department was there and now it's depth. Okay, and there we had the name. Here we are having the employee name. So we should actually compare it with the original data frame because we did some modification to the first version. Here is the annual salary. So the department or column was originally, this column was originally named department. Now it's depth. Okay. And this one was named name and now it is employee name. So this is actually how we rename multiple columns simultaneously. Then if we want, we can have the column's name to be uppercase. In order to do that, we use the rename function again for the df data frame. And then we assign columns to be equal to str.upper. So we are going to uppercase all the strings that are in our columns in the df data frame. So when we come here, we see that this version has all the columns that are uppercase letters. Okay, so this is also how we can do that. And also in order to add a prefix to our column's name, we can use the lambda function. So we first of all call the rename function for the df data frame, then columns equals lambda function for each x, and we are going to add employee underscore before the columns. So here was the original column. So name, age, salary, department. Now we see here we are having employee underscore name, employee underscore age, employee underscore salary, employee underscore department. So employee underscore is added to all the columns name. This is basically how we can use the rename function to work with the names of our columns. Thank you for watching. Welcome back. In today's video, we're going to learn how to change data type in our data frame. So first of all, this is my dictionary called data. I would like to create a data frame from this dictionary. So here is, I'm using the data frame function from the Pandas library, and I'm converting the data dictionary to my df data frame. So df is the name of my data frame. So data frame function called from the Pandas library to convert the data dictionary to df data frame. Now, first of all, let's print the original data frame and also print the data type in this data frame. So this is my data frame. So name, age, salary, department, and we are checking to see if the person is manager or not. So if the number is 0, it means that they are not manager. If the number is 1, it means that they are manager. For example, Bob and David, they are both managers. But Alice, Charlie, and Eva, they're not managers. This is why they're having the 0. And each row is an observation. For example, Alice is 25 years old, 50K salary from HR department, and this person is not a manager. Then these are the data types of our current original data frame. So name, age, they are object or let's say string. The department is also a string, salary is a float, and is manager is of integer data type. So now I would like to change their data type. Now, in order to start, we're going to convert the age data type from string to an integer. So I write down the name of my data frame, which is df. So I'm going to change the age in the df data frame, and I would like it to be integer type for the age column from the df data frame. So on the right hand side is what I would like it to be, and on the left hand side is what it is currently. So now I'm calling the age column from the df data frame on the left hand side, and I'm assigning this to this. So I use the as type function to convert the age column from the data frame df to be integer. Okay, so now and after that, I'm going to use the name of the data frame dot d types to print again the data type of my data frame. So when I look at the output previously, before any conversion, the age was a string, so it is why it is showing object, but now it's an integer. The data type has been changed. Now we learned how we can do that. We write down the integer data type using the as type function for the age column from the df data frame on the right hand side, and on the left hand side, all these things are assigned to the left hand side. Okay. Now I would like to convert salary from float to integer. Again, we are going to use the integer using the as type function for the salary column of the df data frame, and all of this is assigned to the salary column of the df data frame. Therefore, when we print the df data type, so we see that in order to print the df data type, we can simply write down df.d types. Okay, so here again we see that previously in the original before conversion, salary was a float, and now it has been converted to an integer, and now we see that it's an integer. So we changed its data type. Okay, so the next thing is that I would like to convert is manager column from an integer, which is 0 and 1, to boolean. So I write down boolean or bool keyword in the parentheses using the as type function for the is manager column in the df data frame, and all of this is assigned to df is manager. Okay, and again we print the data type, and when we look at the output here, we see that previously is manager was an integer data type. Now it is of boolean, so we converted it. Okay, and another thing in order to uh, convert is the department. So the department currently, when we look at the output, the department is a string. It's an object. So we would like to change it to categorical type, which is going to save memory for us. So again, we use the as type function and we put category for the department column of the df data frame. And the left hand side is the department column of the df data frame. So when I print the data type again, here we see that now the department is a category and it's not an object anymore. Finally, we are going to convert back salary to float again. So we write down the float in parentheses using the as type function for the salary column of the df data frame and assign it to the salary column of the df data frame, and we print the data type of our data frame. So we see that first of all, salary was a float. Then at some point we converted it to integer, and now we are converting it back to a float. So in this video, we learned how we can convert our data types from one type to another in our data frame. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about handling duplicate data. So here is my dictionary. I'm going to create a data frame from this dictionary. So I use the data frame function from Pandas library to convert the data dictionary to a data frame called df. So first of all, I'm going to print this. So when I print this, When I run the code, I print this, and I see that this is my original data frame. So we are having 1, 2, 3, 4, 5, 6 rows, and there are some duplicate data. So we see that we are having Alice and Alice here. So and they are both the same person because the age is the same, the salary is the same, the department is the same. So they are probably the same person. And we are having two Bob. They are again having the same age, same salary, and they are from the same department. So again, it means that we are having a duplicate. So in order to make sure that it's a duplicate, because when we are having a very large data frame, it's hard to manually navigate it. So we can use the duplicated function for the df data frame and assign it to duplicates. And this is going to show us the duplicated rows showing true. So wherever it's a duplicate, it is going to show true. So when I run the code again, we see here. So for the first, second, and third row, there is no duplicate. This is why we're seeing false. But the fourth part, the fourth row, let's say, which is Alice with index 3, okay, this is index 3, it's true. It means that, okay, there's a problem there. We're having duplicate data there. The fourth row, fifth row, it's false, so it's not duplicate, it's unique data. And again, for the sixth row, we see that for index 5, we are having duplicates. Okay, so now we could navigate the duplicates. We are having two rows that are duplicates. So we did that using the duplicated function. Then what we do is that we can remove all duplicate rows and keeping only the first occurrence of them. So in order to do that, we call the drop underscore duplicates function for the df data frame, and it is assigned to df no duplicates, and we are printing df no duplicates. And here we see that, okay, now we are removing duplicate rows and we are keeping the first occurrences of the duplicates, meaning that if we were having two Alice here in the first row and in the fourth row, we are keeping the first occurrence, which is Alice in the first row. So we are having Alice, Bob, Charlie, and Eva. So now it's the data frame that we are having here, and there is no duplicate there. Okay. Now, in order to go further, we can have the removal of duplicates, while keeping the last occurrences. So we call the same function drop underscore duplicates. However, this time in parentheses, we are going to say keep equals last, meaning that keep the last occurrence instead of the first one. If you don't write anything, it is going to by default keep the first occurrence. And all this is assigned to df keep last, and we are printing it out. So here now we see that in the original we were having two Alices, for example, the one in the first row, one in the fourth row, and keeping the last occurrence here, we see that Alice that is in the fourth row is being printed. How do I know that? Because the index is 3. So for the fourth row, the index was 3. For the first row, the index was 0. So we are keeping the last occurrence of Alice, also the last occurrence of Bob, which has the index 5. So you see that here, Bob with index 5 is there, and Bob with index 1 is not there. While we were having Alice and Bob with indices 0 and 1, while we were keeping the first occurrence. Okay. So this is the first thing. And what if we want to remove duplicates based on a specific column? For example, we would like to remove duplicates for all the similar names. For example, I would like to have one Alice, or one Bob, one Charlie, and one Eva. Okay. Even though there might be different people with the same name in our database, it doesn't mean that they are the same person, but we would like to have one Bob in my list only. So I call the drop duplicates function and assign subset to be equal to name for the df data frame and assign it to this name, df unique names, and I print it. When I print that, we see that here we are having the data frame after removing duplicates based on name column. So we are having unique names here in the name column. We can do the same with two or more columns. For example, we can remove duplicates based on multiple columns. Okay. In order to do that, we can have the drop duplicates function and call the subset to have the name and age. So we are removing duplicates based on name and age. For example, the criteria for removing duplicates for us is to remove people who are having the same name and the same age. Probably this is the criteria by which we can identify the same person twice, three times, etc. So if their name and their age is the same, we are going to conclude that okay, they are the same people. This is just an assumption. For example, the company is very small, like we are 10 people, and we don't have two Bobs with the same age. Okay, so this is how we can proceed. Drop duplicates function, subset equals name and age. Yes, for the df data frame, and we assign it to df unique name age. And then I'm going to print that. So when I print that, we see that here, the data frame after removing duplicates based on name and age column. So we see that here, we are having Alice, Bob, Charlie, and Eva. So they are unique people there. But what if I change the age of Bob from 32 to 33? So we are having two unique Bob now. One Bob with 32 years old, one Bob with 33 years old. So when I run this code now, we see that Bob is here actually. When we are removing duplicate based on name, only based on name, we are having one Bob. But when I remove duplicates based on name and age, we are having one Bob who is 32 years old and another Bob who is 33 years old, because there is a difference between the ages. We see that we are going to have them and we're not going to remove them from the uh, output in our data frame after removing duplicates based on name and age. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about using the group by function to summarize data. Here, first of all, is my dictionary called data. In this dictionary, we are having name, age, salary, and department. For the name, these are the people. For the age, these are the ages. These are the salaries, and these are the departments. For example, Alice is 25 years old. She earns $50,000 annually, and she works in the HR department. I need to create a data frame from this dictionary. In order to do that, I call the data frame function from the Pandas library for the data dictionary, and I'm assigning to the data frame called df. First of all, I print this df data frame. So when I run the code, I see this output. So this is my original data frame. Here you see that in this original data frame, we are having the columns name, age, salary, and department as we were having in the dictionary. We see that each row has an observation. For example, Alice, this person is 25 years old with this much of salary from this department. However, Bob is there with 32 years old with 60K salary, and this person works in the IT department, for example. So this is my data frame. Now I would like to learn how to work with this data frame using the group by function. First of all, we would like to group by a single column and calculate the average salary of each department. So we are having one person from the finance department. We are having three persons, let's say three people from the HR department, and we are having three people from the IT department. So I would like to know what's the average salary in each department. In order to do that, we should have this salary, and this salary, and sum them up and calculate their average to know the average salary in the HR. We will do the same for the IT, and because we are having only one person from finance in this data frame, so the average is equal to 80K. But how can we use the code to do this for us? In order to do that, we need to use the group by function for the df data frame. We would like to group the departments based on the average salary. Okay, so we use the group by function for the df data frame based on the department. We are grouping by the department to calculate the mean of the salary. Note that here we are having the parentheses, here we are having the square brackets. Okay, so we are grouping by the department for calculating the average of the salary. Okay, and this is assigned to average salary by department, and we are printing this in the output. Okay, so here when we run the code, we see that the average salary by department, we see that the finance has this average, HR has this average, IT has this average salary as you see it here. But if I wanted to, for example, group by department based on the average of age, I could say instead of salary, I would write down the age. So when I run this code, we see that the average of people who work in the HR is 24-ish, around 24. We are having IT, it's 31. We are having finance, it's 40. And we can group by different things, so we can do it as we want. So now I would just go back to salary. So we learned how to group a single column to have the average salary in that department, for example. Now I would like to have the multiple columns grouping and counting the occurrences. What do I mean? So in the output, let me show you the output first. As you see, I'm having the employee count by department and age. I'm having the one person, this is one person in finance with this age. I have one person in HR with 23 years old. I have two people in HR with 25 years old. Okay, one person in IT with 29 years old, two people in IT with 32 years old. So there are two people in IT like Frank and Bob that are 32 years old, and the other person who works in IT is Eva, and she is 29 years old. So I would like to group by department and age to count the number of employees, okay, based on the age and department. So I write down the group function for the data frame df. Note that in parentheses we are having both age and department. Okay, so we are grouping by two columns, department and age. And we are counting the number of people who are having the same age in the same department. We are assigning the output to employee count. And finally, we are printing the employee count here in the output. And we see this is the output. Okay. So now I would like to group by a column and get multiple aggregate statistics. So let me show you the output first. In the output, we are having salary statistics by department, for example. For example, in the finance department, we are having the mean is this number, the mean is this number, the minimum is this number, the maximum is this number, and the sum is this number. Because we only have one person from the finance department. This is why. And we are having the average of the HR is this number. The salary of the average is 47,666. This is the average salary in the HR with the minimum of 45K and the maximum of 50K. And the sum of the salaries in HR is 1,043, 1,043,000
No, sorry, because there is no comma here, I made a mistake. So 143,000. This is the sum of the salary payment for the HR department. Then we are having the IT department. The average of this salary is 57,666. The minimum is 52K, the maximum is 61K, and the sum is 173,000. Okay, so how can we have these statistics by department? In order to do that, we group by department to aggregate the salary, mean, max, and sum. Okay, one more time. I am grouping by the department for the DF data frame and aggregating the salary based on these four criteria: mean, minimum, max, and average, and sum. Okay, we are assigning it to salary stat and we are printing it here and we saw it in the output. Okay, next we would like to know the range of the salary by department. For finance, it's 0 because we only have one salary now in our data frame. But for HR, the range is 5,000. For IT, it's 9,000. Why? So if you have the maximum minus minimum, you're going to have the range for the finance department. So maximum and minimum, they are the same, so it will be 0. Then we are having the maximum minus minimum for the HR. We are having 5,000. We are having 61 minus 52 for the IT, which is 9,000. In order to calculate that, first we group by department and we apply the salary range for the salary. And the salary range is the call of the salary range function in which we are going to have the maximum minus minimum. Okay. And the output is assigned to salary range by department, and we are having this as a print in the output: salary range by department. And we see it here in the output. Finally, we would like to group by department and transforming data, meaning that we would like to add a group level mean salary as a new column. In order to do that, I can have the group by department because I would like to have a new column, average salary in the department. And in this new column, I would like to have the HR department average salary. Okay, so this is Alice information. In the end, we see that, okay, this person earns 50,000 and average salary is around 47,500. Okay, here again, this is the same average as you see because the department is the same, but Charlie earns less than the average. But how can we add this column here? In order to have that, we are going to have the group by department for the DF data frame, and we are going to transform, meaning that we're going to create a new column of the mean of salary in those departments. Okay, this is assigned to def data frame as the average salary in depth, as you see here. So this is the new column. So the new column is created here based on the average salary of each department using the group by function for the DF salary. And then we are printing the DF. So the original data frame is now updated. So in this video, first of all, we learned how to create our data frame, how to group by a single column, by multiple columns, and how to group by column and get multiple aggregate statistics. Also, we calculate the range of the salary and we learned how to add the average salary column in the original data frame. Thank you for watching.
Hello everyone, welcome back. In today's video, we're going to work with the group by function and work with some aggregation function like sum, mean, and count. So first of all, this is my dictionary. I'm having a dictionary called data, and there are three categories: department, salary, and age. And these are the departments, these are the salaries, and these are the age. And I would like to create a data frame from this dictionary. So I'm having a data frame function from Pandas library to create the df data frame from the data dictionary. So first of all, I print the data frame that I create here. So this is my data frame. We are having three columns here: department, salary, and age. Then we are having each row representing an observation. For example, in HR department, there is a person with this salary, with this age. So maybe this is some information that you might have in your company where you remove the name of the people just to keep the privacy of the data. So now I would like to calculate the total salary in each department. So this is the output. The total salary in the finance department is 80K, in HR is 143K, and in IT is 173K. So these are the total salary in each department, that these are the costs, let's say. So in order to have the summation of that, we are grouping by the department and we are summing over the salary. Remember that when we are using the group by function, we are having the parentheses, so we are grouping by department for salary summation in the df data frame, and we are assigning the output to the total salary, and we print this total salary that we see here in the output. Okay. Now, in the next step, we would like to calculate the average salary in each department. Okay, so the average salary in finance is 80K, the average in HR is 47, around 47, and in IT department it's 57,666. So this is the average salary in IT, this is the average salary in HR, and this is the average salary in finance. And in order to calculate this average salary, what we can do is we can group by department for the df data frame for the salary average. Okay, so we use the mean function and we assign it to average salary, and simply we print average salary in the output. Okay. So in the end, we would like to count the number of employees in each department. So we see that in finance we have 1%, in HR we are having 3%, 3 people, in IT we are having 3 people. In order to do such a thing, we can use the count function to count the number of employees in each department. So we are going to group by department for the df data frame, and we are going to count how many salaries do we have in each department. Okay, because each salary represents one person. So we're going to count how many salary do we have in each department in the df data frame using the group by function. And this is assigned to employee count, and we are going to print the employee count in the output. So looking at the output, we see that in finance we have 1%, HR and IT each is having 3 people. So in this video, we learned how to use the group by function to aggregate data using the sum function, mean function, and the count function. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about multi-level grouping. So first of all, here is my dictionary called data. It has 4 categories: department, location, and salary and age. You see that here we are having different departments like HR, IT, HR, finance, etc. Then we are having the location. So this HR department is in New York, and the salary is 50K, and the age of the person is 25. So there is one person who works in the HR department in New York with this salary, with this age. There is another person who works in IT department in New York with this salary, with this age. Okay. There is another one in HR in LA with this salary, with this age. Okay, so this is my dictionary. Now, I would like to use this dictionary to create my data frame. In order to do that, I call the data frame function from Pandas library for the data dictionary to create my df data frame. First of all, I'm going to print the df data frame. So here is my df data frame. You see, these are the columns: department, location, salary, and age. Then here for the first row, for example, we are having one person. For the privacy, for example, if you're having access to some information from your company, for privacy reasons, you may not be able to see the name of the people, etc. So this is like that. This information is like that. So we don't have the names for just the privacy of the data, but this is just a small example that I'm providing here. So in the first row, we are having someone from HR located in New York with this salary and this age. And for example, in this row, we are having another person in finance department in San Francisco with this salary, with this age, for example. So this is my original data frame. Now I would like to group by multiple columns, department and location. So I would like to group by department and location to calculate the average of their salary. So we're grouping by, note the parentheses, department and location for the average of salary using the group by function for the df data frame and assigning it to group, and we're printing the group here in the output. And the output is this. So we see that here for the finance department in San Francisco, the average salary is this, 75,500. Then for the HR department in LA, the average is 46K. In New York, it's 50K. In San Francisco, it's 48K. Okay, so these are the average salaries based on the location and the department. Okay. And then we are having the IT department in LA with 52K as the average salary, and in New York with the 60,500 salary average. So this is basically how we can group by department and location to calculate the average salary. And finally, we would like to have the grouping by multiple columns, getting multiple aggregations. For example, I would like to group based on the department and location at the same time to aggregate these and this information for the salary. Okay. So the grouping by department and location for salary to aggregate this information, sum, mean, and count of the salaries. So when I see the output, we see that here we are having the department and location. We are grouping them by department and then location. And for example, for finance in San Francisco, we have the sum of the salaries to be 155,000, and this is the mean, or let's say the average salary, and this is the number of uh, people who are there in the San Francisco in the finance department. Okay, then we are having the HR department in LA, and the sum of the salary is 92K. The average is 46K, and the number of people who are there, there are two people there only. Then we are having one person with this salary, and therefore this sum with the average of this and sum of this in New York in the HR. We are having the San Francisco report for the HR. We are having the LA report for IT, and we are having the New York report for IT as well. So in this video, first of all, we learned how to create our data frame. Then we learned how to group by multiple columns, like department and location, to calculate the average of the salary, and also to group by multiple columns to calculate the aggregation functions for the salary when we are grouping by department and location. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to work with sorting values using sort underscore values function. So first of all, this is my dictionary called data. This dictionary has different categories: name, age, salary, and department. So these are the names, these are the ages, these are the salaries, and these are the departments. For example, Alice is 25 years old, and this is the salary of Alice, 50K, and this person works in the HR department. So first of all, we need to create our data frame from this data dictionary. So I call the data frame function from the Pandas library for the data dictionary to create the df data frame. So I print the original data frame, and this is the original data frame being printed here in the output. Now I would like to sort a column. Now I would like to sort the column age. You see, these are the columns that I have for my original data frame. Now I would like to sort the data frame based on the column in ascending order. In order to do that, I call the sort values function for the df data frame, and I mentioned sort it by the age. And by default, it is going to do the ascending order sorting. The output is assigned to df sorted age, and we are going to print it here in the output. So when we are looking at this sorted data frame based on age, we are going to have 23, 25, 25, 29, etc. until the end. So this was the age, like Alice was the first person. Now Charlie is the first person because the Charlie is the youngest, and then 25, etc. You see that there are differences between the original and the sorted one by age in ascending order. But what if we would like to sort a column in descending order? How can we do that? Now I would like to sort based on salary and in the descending order, meaning that I need to assign ascending equals false. Okay, so I call the sort values function from the df data frame for the df data frame to sort by salary column in descending order, because we are assigning ascending to be false. So now this is my sorted by salary in descending order. So the largest salary is in the first row, which is for David. Then we are having 61K for Frank, then 60K for Bob, then 52K for Eva, etc. until the end. So now we are having the sorting in descending order. But how can we have the multiple columns sorting? So we can have the sort first by department and then by salary. And I would like to be the department to be in ascending order and the salary to be in descending order. So I call the sort values function for the df data frame, and I am sorting by, you see here, so I'm sorting by department and salary, and ascending keyword is assigned to be true, which is for the department, to be false for the salary. False means that do the sorting for salary in descending order, and true means do the uh, sorting in ascending order for the department. Okay. So now we are going to have our new data frame. First of all, the departments are in ascending order. So F is first because we are having the A, B, C, D, E, F. Okay, so F is first among HR and finance. Finance is the first because it starts with F. And then we are having the HR starting with H and IT starting with an I. So it is now sorted by departments in the ascending order. Now I would like to have the salaries in descending order, or let's say high to low. So now we see that this person, David, is in the finance department who earns more than the others. Then we are having this person 50K. This person Alice earns in the HR department, and this person is earning more than anyone else in the HR department. We see and 48K is for Grace and 45K is for Charlie. However, for Frank, this person earns 61K, which is higher than Alice, but because we first sorted by the department, Frank is going to be first person in the IT department, okay? So the first person in the IT department is Frank, then we are having Bob, and then we are having Eva. And the reason why Frank is here and not above Alice is because we sorted firstly based on the department and then based on the salary, okay? So in the IT department, the most salary goes for Frank. So in this video, we learned how to sort values in ascending order, in descending order, and also we learned how to sort multiple columns. Thank you for watching. Hi, welcome back. In today's video, we're going to learn how to rank data using the rank function. So here is my dictionary called data. It has 4 categories: name, age, salary, and department. And these are the information. This is the information for the name, age, salary, and then the department. For example, Alice is 25 years old with 50K salary from the HR department. So I would like to create a data frame for the data dictionary using from the Pandas library and assign it to df data frame. So in order to create the data frame, I call the data frame function from the Pandas library for the data dictionary, and it is assigned to df, which is the name of my data frame. Now I would like to start ranking it based on the salary. Okay, so in order to rank it, let me first of all show you the data frame. So this is the data frame. 4 columns: name, age, salary, and department, and each row has an observation. So Alice is 25 years old and with the salary of 50K from the HR department, for example. And now I would like to rank it in ascending order. What do I mean by ranking it in ascending order? So I would like to have the salary rank to see who is earning more than the other people. So we start with Charlie, who earns the lowest amount of money in the department, and we rank it to be the number 1, meaning that this person is earning the lowest salary. And then we are having here Grace as the second lowest person, lowest salary. Then we are having Alice, etc., until we reach the last person, which is rank 7, and David is earning more than anyone else in the company. So ranking in ascending order means that we start with the lowest salary. Okay, in order to do that, we call the rank function. And we would like to rank based on the salary column of the df data frame, and we are going to have it in a new column called salary rank. Okay, and we are going to print the data frame one more time, and we see that here the data frame indeed is having a new column that is salary rank, and in ascending order by default it is calculated. Now what if I would like to rank salaries in descending order this time? This time I do the same thing. So I write the rank of the salary in the df data frame, but in parentheses instead of, because when you have nothing, it is going to consider it you're doing it in ascending order. Here instead I'm having ascending equals false, meaning that you're going to do it in descending order. And this is assigned to be the new column called salary rank descending order in the df data frame, and we are printing the df data frame one more time, and we see that we are having this new column salary rank descending. And now the first number represents the person who earns more money than the others. Okay, for in descending order, number 1 is the highest salary and number 7 is the lowest salary. While we were having in salary rank in ascending order, number 1 was for the lowest salary and number 7 was for the highest salary. So in this video, we learned how to rank our data using the rank function. Specifically, we learned how to rank the salary based on the ascending order ranking or descending order ranking. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about concatenating data frame. So in this video, we are having, first of all, two dictionaries called data1 and data2. In the data1, we are having three categories, ID, name, and salary. The same categories are in data2, ID, name, and salary. But the data is a bit different. So the ID is here 1, 2, 3. Names are Alice, Bob, Charlie, and then the salaries are 50, 60, and 45k. Then in the data2, we are having IDs that are 4, 5, 6, name David, Eva, Frank, and these are the salaries as we see it here in our dictionary. Now the thing is that we would like to create data frame based on these two dictionaries. So if the first data frame is created using the data frame function from the pandas library for the using the data1 dictionary, and the first data frame is called df1. We use the second data2, we use the data2 dictionary, let's say, to create our second data frame that is called df2. Okay, so first of all, we are going to print them in the output. So this is the data frame 1, and data frame 2. So this is data frame 1 and this is data frame 2. So here we see that we are having three columns: ID, name, salary, and then the relevant information. For example, in the first row, we are having ID1. The person with ID1 is Alice, and then this is the salary. We are having Bob, Charlie, etc. in the first data frame, and then we are having the second data frame that has the same columns, ID, name, and salary, but we see that the information is different, and we are having ID 4, 5, 6, and for example, the ID 4 is David with the salary of 80k. Now we would like to concatenate data frame along rows. Okay, what do I mean by along rows? So I'm going to show you the output first, then we are going to discuss how we can do it. So we are concatenating data frame 1 and data frame 2 based on rows. Okay, so we see that we are having the same columns here, ID, name, salary, ID, name, salary, in both tables, in both data frames, let's say. Now I'm having the same columns here, and we start with data frame 1. So Alice, Bob, Charlie, Alice, Bob, Charlie, they are there. Then David, Eva, and Frank, David, Eva, and Frank, they are also there. So we see that here we are concatenating based on rows, and in order to do that along rows, we call the concat function from the pandas library for data frame 1, which is df1 and df2, and we assign it to df concat rows. Okay, and we are printing this in the output. So this is the data frame along rows, that the second data frame is added along the first data frame. But one thing that we see here is that indexing here it's 0, 1, 2, and here again it's 0, 1, 2, because index in the first table, indices in the first table were 0, 1, 2, and then here it was also 0, 1, 2. So because we are taking data from data frame 1 and 2 to concatenate them, we are having 0, 1, 2 rather than 0, 1, 2, 3, 4, 5. Okay, so in order to do that, to have a resetting of the indices, we are needing to call the reset index function for our new concatenated data frame, that is called df concat rows, and in parentheses we assign drop to be true, and this is assigned to this df concat row reset, and we are printing it here in the output. So when we see the output, we see that now this concatenated data frame is exactly like this one, but the indices are updated, so 0 to 5, but here it was 0 1 2 0 1 2. Okay, so you see that here we are resetting the indices. Now after that we are creating another data frame, but this is the data tree dictionary with ID and department, so 3 IDs and 3 departments, they are there. Then we are creating the data frame. In fact, we are calling the data frame function from the Pandas library for the data tree dictionary and assign the name of the data frame to be df3. And first of all, we are going to print the df3. So this is my new data frame, the third data frame, ID and department. So IDs are 1 2 3 and departments are HR, IT and finance. Then we would like to concatenate data frame now along columns, so the third data frame and the first data frame. So I call the concat function using the from the pandas library. Then we write down df1 and df3 because these are the data frame that we would like to concatenate. Then because we would like to concatenate along columns, I would have to write down access equals 1. We assign it to be the df concat columns and we print it in the output. So when I look at the output, here we see that we are having the columns from the first data frame, and then we are having the columns from the third data frame that are ID and department. So now, because we did the data frame along columns, we did the concatenation along columns, we are having the columns of the first data frame that are ID, name and salary, and the columns from the third data frame that are ID and department. And each row again is an observation. For example, here we see that here Alice is having this much of salary, the ID is 1, and this person is from the HR department. Okay, so this is how we can concatenate along columns. The important thing is to know that we need to assign access to be equal to 1, so the compiler understands we would like to do the concatenation along columns. Now we are having the fourth dictionary that is called data4, and this is it has 3 categories: ID, name and age. We see that IDs are 7 8, the names are Grace and Hank, and the ages are 30 and 27. So first of all I print this, so first of all I create my data frame from the data4 dictionary, call the data frame function from the pandas library, and data4 from the data, using the data4 dictionary to create my df4 data frame. Now I would like to concatenate data frame 1 and 4 with different columns. Okay, so now I call the concat function from the pandas library for the df1 and df4, and I would say ignore underscore index equals true. This is assigned to be df concat mismatch, and we print the mismatch in the output. So when I look at the output, here is my concatenated data frame. So you see that here we are having ID, name, salary and age, and for the first 3 rows that the data comes from the df1, we have the name, we have the salary, but we don't have the age. So you see that for ages we are having missing values. Then for the df4 that is concatenated in this new data frame, we are having the Grace and Hank with the ID 7 and 8. We know their age, but we don't know their salary. So looking at the data frame 4 that was created based on data4 dictionary, we see that yes, salary is missing here. So we are concatenating it with another data frame and in the other data frame the salary is there, but for them, for the df4, we don't have the salaries, therefore we are having the missing values. The same happens here with the data frame 1. So they are having the name salary, but age it's missing. Okay, so this is the original data frame 1, so age is not there. This is why we are going to have missing values. Okay, so this is how actually we can concatenate data frame with different columns, and the columns that are not originally in one data frame, they are going to be shown as missing values. And also we can have the concatenating with an inner join. Let me show you what the inner join means. So here is the concatenation using the inner join. It means that basically we are going to have common columns only. So for the data frame 4 and data frame 1, the common columns, you see that here, this is the data frame 1. So age is the missing value, so this is not the original column for the data frame 1. Therefore, ID, name, and salary are the original columns from the data frame 1. And in these two rows that we are having from data frame 4, ID, name, and age are the main columns. Okay, but for salary it's not the column of the data frame 4. This is why we are having missing values. Now if I want to find the common columns between data frame 1 and data frame 2, we can see that ID and name, these two columns are the shared columns or the common columns between data frame 1 and 4. Okay, salary is only for the first data frame, age is only for the fourth data frame. Therefore, we are going to have the concatenated data frame using inner join, meaning that we are going to have only common columns only. So we see that ID and name, we are having the ID and name, the common columns, and we are having IDs like 1, 2, 3, 7, 8, and the names are Alice, Bob, Charlie, Grace, and Hank. So in this video, we comprehensively reviewed the concatenation of data frames. First of all, we learned how to do the concatenation along rows. We learned how to reset the indices. We learned how to concatenate along columns, and we learned how concatenate data frame with different columns. Also, we learned how to concatenate with an inner join. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn about merging data sets using the merge function. So first of all, we need to create two sample data frames. I have a dictionary called employee. Their ID, name, and department is there. And the ID, we're having 5 IDs here from 1, 2, 3, 4 to 5. And then the names are Alice, Bob, Charlie, David, and Eva. Then we are having the departments that are HR, IT, HR, Finance, and IT, meaning that the Alice has the ID 1 and this person works in the HR. Okay. Then we are having the salaries, and the salaries we are having the ID, so the salaries are 1, 2, 3, 4, and 6. 5 is missing. We don't have the salary of the person with ID 5. But here we are having the salary of the person with ID 6, and we are having the salaries here. So for example, the person with ID 6 earns 55,000 per year. But here you see that in employee dictionary, we don't have the information with respect to the person with ID 6. Okay, so the first one is missing the ID 6. The second one is missing the ID 5. Okay, now I would like to create my data frame from these two dictionaries. I call the data frame function from the Pandas library for the employee dictionary. So I create the df employees data frame, and then I do the same for the salaries dictionary to create the data frame of salaries. So we are having them here. So first of all, I'm going to print these two data frames. So this is the data frame of employee. We are having ID from 1 to 5. Bob is for example, is with ID 2, and this person works in IT. And here we are having the salary data frame from ID 1 to 4 plus ID 6. We don't have the ID 5, so we don't have the information regarding the salary of Eva, but we are having the information regarding Bob. For example, Bob, whose ID is 2 and works in the IT department, this person earns 60,000 per year. Okay, so this is what we know from these two data frames. Now we would like to merge them. In order to merge data frame using inner join, which is the default, we are going to call the merge function from the Pandas library for data frame employee and data frame salaries, and we are going to have the merging inner join based on the ID, and the output is assigned to df inner, and we're going to print the df inner in the output. So we are having the inner join on ID. Here we see that only the shared ID among these two data frames are shown here. So here we are having from 1 to 5, here we are having from 1 to 4 plus 6. So 1 to 4 is the common IDs. So in the merge data frame we are having only from 1 to 4, and these are the names, these are the departments, and these are the salaries. Okay, so far we learned how to have the inner join on ID. Now I would like to have the merging using the left join, or let's say I would like to keep all the employees. In order to do that, we call the merge function from the Pandas library. We are going to write the same thing, the data frame of employee, data frame of salary. We are going to merge based on the IDs, but how? We are going to have the left join. Okay, it is assigned to df left, and we are printing df left. It means that we are going to have all the information regarding the first data frame employee. So this is the left join all employees. So we are having it here. We see that from 1 to 5 is there, everything about 1 to 5 is there, which was shown here in the employee data frame. We are having 1 to 4 ID, name, and department. So ID, name, and department. With respect to the salary, however, we are having the salary up until from 1 to 4. Okay, from the second data frame, which is the salary. For the Eva, we don't have the salary. If you remember, this was the data frame for the salary. You see that with ID 5 we don't have anyone, so Eva's salary is missing. Therefore we are having a missing value in the left join when we are having all employees. Okay, if we want to do vice versa, we are going to have the right join, meaning that we are going to have the right join with all salary records, meaning that we are having the salary data frame from 1 to 4 plus 6. So from 1 to 4 plus 6, and we are having the ID, name, department, and salary. But here you see that for the person with ID 6 we are only having the salary because that is coming from here. But in the first data frame we don't have the information regarding the person with ID 6. Therefore we are having the name and the department being missing there. So salary is this one, but the name and department is missing, and ID is 6. Okay, so this is the right join. How can I do that? In order to do that, I call the merge function from the Pandas library. I have the data frame of employees, data frame of salaries, and we are merging on IDs, and how we are going to have the right join, and we are printing the data frame right. This is basically what we see here in the output. Okay, now what if we want to have the outer join? The outer join is this one. So this is the outer join, meaning that we are going to have all records from both data frames. Okay, so we are going to call the merge function from Pandas library. We are having the data frame employee, data frame salary, based on ID. We are having the outer join. How? Outer. Okay, so it is assigned to df outer, and we are printing the df outer. So when looking at here, we see that from 1 to 6, from 1 to here is the outer join. So we are having, when I run, yeah, so here we are having from 1 to 6 in the output. I had to rerun the code, sorry. So we are having from 1 to 6. So all the information from both data frames are here. For the first 4, we are having data for the first 5 ones, like 1, 2, 3, and 4 here. Sorry, for the first 4 rows that they are in both data frames, we are having all the information: ID, name, department, and salary. For the person with the ID 5, who is Eva, we are having the name and department. We don't have the salary. And for the person with ID 6, we are having only the salary and we don't know the department and the name. So to summarize, first of all, we worked with the data frames. So we created 2 sample data frame, employees and salaries. So first we learned about the merge data frame, or let's say inner join. Inner join is going to give us the common rows based on ID we set. Okay, inner join on ID. So the common IDs in both data frames are going to be shown here. Then we worked on the left join for all employees, meaning that whatever that is inside the first data frame or employee data frame is shown here. Okay, even though we are having some missing data, missing values. Then we work on the right join for all the salary records, and all the salary records is this one. So we are having all the IDs from this data frame, all the IDs from this data frame, but we are not having the name and department of the person with ID 6. And finally, we learned about the outer join, which is going to give us all the record of both data frames. So from 1 to 6 we have, and we are having some missing values here. For example, salary of Eva and name and department of the person with ID 6. Thank you for watching.